Hello everybody. Hello Mirandariki. Hi. Good afternoon. So, how is your day going on, Andariki? Sir, why are you taking the classes on holidays also, sir? We are having a lot of work. Why do you keep taking classes on the holidays also? Hi, Gitanjali. Hello everybody. Hello. How is the energy? It looks down, right? Hey, all of you, like the video and hit the comment sections. How is the energy? Tell me, all of you. So today only we will be trying to cover two chapters. First is the gravitation. Second, maybe electromagnetic induction. Our magnetic properties are completed. Okay? The next chapter I am interested in is electromagnetic induction. If possible, we will be trying to finish that chapter in this class. I mean, on this day itself. Okay? Yeah. So one class for your gravitation. Then we will be moving towards your electromagnetic induction. Yeah, let me just inform. All right. Okay. So, starting from the gravitation, as you all know, in your 9th class, 10th class, gravitation chapter was there, kada? So in that we talked about gravitational force, F is equals to gm1 m2 by r square. This was all that we discussed. Dan tarvata we left it everything on God only. I know only this much, sir, and I don't know anything other than that. Kani we will be discussing the gravitation in a little depth. Depth and enti, sir, ma daggara Newton's law of gravitation undi. Then we talk about the superposition. Then we talk about gravitational field. Dan tarvata gravitational potential. Then acceleration due to gravity. Sir, orbital speed. Sir, motion of satellites. Sir, escape velocity. Gravitational potential energy. Ade. Okay, so these are the all topics, subtopics I want to cover in today's class. Andariki, chuskondi. Once we are done with these topics, this chapter will be completed. So starting with the first topic pair endira. It is known as Newton's law of gravitation. Chuskondi andariki. Hey, too much thickness, re. I think. Okay, so the first topic, too much thin, re. What is happening with this? I don't know. So the first topic will be Newton's law of gravitation. What does it say? Cheppandi. Newton's law of gravitation. Newton's law of gravitation ante enti, sir? It all depended on the mass. you understand one thing, okay? I'm telling you in a very deep way. The most astonishing thing in physics, what I'm telling, hey, చూసుకోండి అందరికి. The most astonishing thing in physics, what? Is what? The most astonishing thing in physics is your అదే ఏం మాట్లాడుతున్నావు సర్జీ? మాస్, most astonishing thing. Yes. If you look at theory of relativity, ఆ పర్స్పెక్టివ్ నుంచి కూడా, లేదా you look at a given scenario, I will tell you an example అందరికి చూసుకోండి. So this is me, and this is a train రా, చూసుకోండి అందరికి. So this is a train, okay? It's a train made by heavy engineers రా. Too much of research work, దాని తర్వాత too much of assembly, too much of metals collection and all these things, then they made this train. It's very heavy. Heavy ante enti sir? The mass of this train is too much. Ade kada, mass is huge. The mass of this train is huge, sir. Okay, can I lift this train? No. Can 10 people lift this train? No. Can 100? No. Sir, it's too much heavy. Ade kada? Yes. So for me, my capacity, for my world, for my universe, this train is unliftable. Ade kada? Yes. So oka roju suddenly there came an alien ra. Alien ante chusko. This is the size of that alien. Okay? So this is the alien. This is the alien ra. Okay? Where I am? I'm here. Where I am? I'm here. Alien is here. Ante kada? Do you think he will be able to lift the train? Huh? Do you think that alien will be able to lift the train? Yes, he will. Enduku sir? Because his mass is more. Ante all the physics laws that I was having in my world, they are nothing for this alien. Are they the same thing? If you look at the microscopic level ante enti ra? Electron, proton, neutron, at that level if you look, mass keeps no significance. Enduku sir? Because mass of electron is 9.1 into 10 to the power minus 31 kgs. It's a too small mass ra. It's too small. So sir, gravity does not act on it. Chuskondi, cheppandi. Does the gravitational force keep any significance in the scenario? No. If mass of electron is me, you cannot say that there will be gravitational force between electron. Ante kada? Yes. So if your mass is very small, all the laws of physics will change. Ardhamaindi andariki? If mass is very small, all the laws of physics will change. Quantum physics antaru. If mass is too much, ade kuda mass ante all the laws of physics will change. Black holes, wormholes, are you understanding? Something like that. Tunneling, quantum tunneling and all these things. So mass is the most astonishing thing in physics. I don't know, but it should be very clear to you. I don't know if you are observing this world with open eyes or not. Okay? There was a sugar crystal ra. Okay, sugar crystal fall on the ground. There are 10-20 ants. They want to lift that sugar crystal. Will they be able to lift? Ledanti. Why? Mass is more. Kani na kosam, it's too simple to lift. Ade kada? Yes. Based on the same concept, there are a lot of movies also. Movies lo, there is the alien whose size is massive. It comes into the society where the size of the people is very small. And then he performs some extraordinary activities for those people. Ante kada? Yes. Mass is the most astonishing thing in physics. And if mass is small, physics will change. Our physics, we will call it as quantum physics. If mass is moderate and 80, sir, the mass that is average for you and me, 30 kgs, 20 kgs, 5 kgs, 100 kgs, ton, quintals and all these things, okay? We will call it something else. But if the mass gets too much heavier, ante chala pedda mass, for example, black holes. What is the mass, sir? Mass is too much mass. Akkada kuda our normal physics does not work re. Normal physics does not work for a black hole. Then you talk about Schwarzschild's radius, then we talk about the accretion disks of a black hole and all these things. Ade kuda that's a very different physics. It's not for us. Okay, yes, చూసుకోండి. There is one more aspect of mass. ఏంటి sir? Mass according to Albert Einstein, it is not a constant quantity. అంటే ఏంటి sir? If mass is moving, that means its mass also changes. Formula is m is equals to m naught divided by root of 1 minus v square by c square. Hey, చూసుకోరా, if there is some object, you understand something, okay? If there is some object that's moving at a speed of light, and its mass must become zero. Mass becomes zero and the object, it will get vanished. Okay? Right. That's why I told you the most astonishing thing in physics is mass. Okay? The most astonishing thing in physics is your mass. So based on this same mass, there were scientists 400 years ago. 400 years ago, scientists enti sir? Newton. Isaac Newton ra? Yes. In India, there were Mughals. And in London, there was Newton. Okay? We were fighting for freedoms and he was inventing something else in London. చూసుకోండి. Newton, based on all those observations, చూసుకోండి. It's a story, it's a widely famous story that one day Newton was sitting under a tree, an apple fell on the head and all these things. I don't know the credibility, okay? We don't talk about the credibility. Kani. This whole experiments of these gravitation force were started even before Newton. And Newton took all the conclusions and made a law. What was the law, sir? నా దగ్గర 2 masses ఉంటే this mass is m1, ఎక్కడ వచ్చి this mass is m2. చూసుకోండి అందరికి. Let us say the distance between them is r. Masses గురించి మాట్లాడుతున్నావు. It does not talk about shapes. It does not talk about volumes. Only masses. Masses అంటే sir, whatever can be the shape. Yes, you take whatever shape you want. The masses have the tendency to attract. చూసుకోండి రా, gravitation has huge similarity with your electrostatics. Gravitation has huge similarity with your electrostatics. The only point that differs is electrostatics lo charges were attracting, they were also repelling, right? Positive repulsion, negative repulsion. Kani ekkada vachi the mass will not repel. This is the only change in gravitation and electrostatics. Difference between gravitation and electrostatics. చూసుకోండి. What did Newton say? Point number 1. Mass attract another mass. This is the point number 1. Mass attracts another mass. Finish. Attract ante enti ra? Attract ante force. ఈ force ni we will call it as gravitational force. ఇదే కదా? Yes. So ఎప్పుడైనా మీ దగ్గర ఒక mass ఉంటే you must say that it is attracting another mass, sir. In room there are multiple things. I am also having some mass. This board is also having some mass. At the same time, the laptop or the computer is also having some mass. So does that mean all of us are attracting one another? Yes. Each and every mass in this universe, not on the earth, not on the specific planet, entire universe law. It is a universal law of gravitation. చూసుకోండి, చాలా important, okay? It's very important law. Every mass in this universe attracts another mass. ante kada? Yes. So if I have first mass, it is attracting the second mass. చూసుకోండి. The direction keeps immense significance. How do you say, sir? My m1 is attracting m2. Attracting m2 ante there is a force on m2 by m1 towards the left side. Similarly, if m1 is attracting m2, m2 will also attract m1 kada? Yes. So the force on m1 due to m2 is in the right side. అర్థమైంది? సో ఇప్పుడు ఈ ఫోర్స్ గురించి మాట్లాడతాం అందరికి చూసుకోండి. వాట్ డిడ్ న్యూటన్ సే? ద సెకండ్ ఎక్స్ప్రెషన్ ఇస్ దాట్ ద ఫోర్స్ ఆఫ్ అట్రాక్షన్, ఫోర్స్ అంటే ఫోర్స్ ఆఫ్ అట్రాక్షన్ ఇదే కదా, ఫోర్స్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు ద ప్రోడక్ట్ ఆఫ్ ద మాసెస్ ఇదే కదా. ఎస్, product of masses. Next, ante force is directly proportional to product of masses m1 m2. Similarly, what did it say? Force is inversely proportional to the square of the distance between them ide kada. Yes, square of the distance between them. అంటే ఏంటిరా? ఫోర్స్ ఈజ్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు ఆర్ స్క్వేర్. నా దగ్గర రెండు ప్రపోర్షనాలిటీ ఉన్నాయిరా, ఫస్ట్ వన్, సెకండ్ వన్. నౌ ఐఎమ్ గోయింగ్ టు క్లబ్ దిస్ టూ అండ్ గోయింగ్ టు ఫార్మ్ అ థర్డ్ న్యూ ప్రపోర్షనాలిటీ, లేదా యూ కెన్ కాల్ ఇట్ అన్ ఈక్వేషన్ ఆల్సో. అంటే force is directly proportional to product of the masses and inversely proportional to distance between them ide kada. You remove this proportionality symbol and you introduce one more proportionality constant, g m1 m2 by r square. G is a proportionality constant, okay? From this equation point of view, for us g is the proportionality constant. Yes, Gonad, g and g are different, very different, okay? G and g are different ra, chuskondi. So here your force is this. Sir, what is this g, sir? G must be calculated experimentally. That is something Newton has done and it must be credited to Newton only. He has successfully calculated the value of universal gravitational constant g, 6.67 into 10 to the power minus 11 Newton meter square per kg squared. Units kuda gurtundali, okay? You understand, this is the value of g. This g and this g, they are different, okay? Both are different. We will see, chuddam andariki, the relationship between each and everything, okay? Very good. G is the universal gravitational constant. Now my question is why f is equals to g into m1 into m2 divided by r squared? Why? Sir, it could be g into m1 plus m2 divided by r square. Sir, why is it not like this? Why is it not like this and why only m1 m2? This is a twist. This is why the scientists spend their entire life to know if it is multiplication, addition, subtraction, division, power, root, indices, exponential, logarithm, whatever it is, okay? Scientists spend their entire life to form just a single equation. Ade kada. Physics law, whatever you are saying to the scientific world does not keep any importance if you don't have an equation ra. Oka valid equation undali. Then and only then your words will be considered as a reliable words. Understanding? If you don't have a valid equation, whatever you say, it will just be considered as a theory. Theory tells a theory of relativity, theory of gravitation. Kani gravitation is not theory anymore. It's a law of gravitation. Are you understanding? Yes, Maitri, very good afternoon. Okay. So it's by nature, okay? Hi. Good afternoon. Good afternoon, Andariki. Yes. So, sir, why multiplication? Why not addition? The simple reason is because the universe, the nature, God, Bhagwan, Dev, he has already decided these things, okay? Already decided. So, the rules that are made by the nature must be followed by every element in this nature. Ante, even if you have your mass, you don't know, but it is following this rule directly or indirectly. So, sir, Two masses attract one another. Sir, నా దగ్గర 10 kg ball ఉంది. ఎక్కడ కూడా this is 20 kg ball, sir. And I am placing them on a ground, sir. Why they are not attracting? Why they are not attracting? చూసుకోండి. Why they are not attracting? Because the value of G is very small. 10 to the power minus 11. Minus 11 అంటే తెలుసా 0.000000011 times. Calculate the force, ra. If you are saying that the distance between them is 2 meters, calculate the force of attraction. Sir, F is equals to G into M1 into M2 divided by R squared. ఇదే కదా. G value అంతారా 6.67 into 10 to the power minus 11. M1 value how much, sir? M1 value is 10. M2 value is 20 divided by R square అంటే radius square అంటే 2 square అంటే 4. ఇదే కదా. Yes. So sir, 4 ones are 4, 4 5s are 20. So it is equals to 6.67 into 10 to the power minus 11 into 50. ఇదే కదా. This is the force. అంటే ఏంటిరా? F is equals to, it becomes 6.6, approximately 6.6 తీసుకోండి. అదే కదా. Yes. So it becomes 6.67 into 10 to the power minus 10 into 5. అదే చూసుకోండి రా. 33.35 into 10 to the power minus 10 Newton. This is the force, sir, between these two objects. Yes, ground is attracting the ball. Yes, very good. But even at the same time, these two balls are also attracting one another. Every mass attracts another mass. Choose it's a very important thing. Okay. So this force tells us 33.35 into 10 to the power minus 10 Newton. Ante the force is 0.1234567893335. ఇది చిన్న ఫోర్సా పెద్ద ఫోర్స్ రా? Do you think this force keeps any significance? Very small force, very small. అదే gravity does not keep any significance for smaller masses. Smaller masses అంటే తెలుసా? Smaller masses అంటే the mass of you and me, the mass of train, the mass of car, the mass of bus, the mass of pyramids. Are you understanding? These are smaller masses. So sir, what are bigger masses, sir? Bigger masses అంటే చూసుకోండి. Mass of a black hole. Let us say 6 into 10 to the power 40 kg ra. Are you understanding? It is a big mass in physics. So gravity, it's a big mass force. Ante enti ra? One day you go to Ambani's house. You go to Ambani's house. Do you think he will ask you? Are you understanding? Yes. Ade. So the level should match to talk. Adhe kada? Yes. So for gravity, this is the level of the masses that we have to take, ra. You cannot talk about gravity by taking 30 kg mass, 40 kg mass. No, it is useless. But when the masses take huge forms, huge numbers, then gravity plays extraordinary games, ra. Are you understanding? Then you can talk about black holes. Then you can talk about wormholes. Then you can talk about the universe traveling from one universe to another universe. Then you can talk about going into the past, time traveling, all these things. Are you understanding? It is all the features of gravity only. Gravity. Ade మొత్తం కోసం your masses should be extremely heavy. Are you understanding? 6 into 10 to the power 40 kgs. You can say if you have two objects, sir, this is my first object, mass is equals to 6 into 10 to the power 40 kgs. Ide na mass M1 ra, చూసుకోండి. Similarly, this is my mass M2. M2 is equals to, sir, 4 into 10 to the power 60 kgs. And let us say, sir, the distance between them is D is equals to chala pedda distance ra, 10 to the power 10 meters. Are you understanding? It's a great distance actually. ఇప్పుడు చెప్పండి, what is the gravitational force, sir? Sir, F is equals to gm1 m2 divided by r squared. అదే కదా. G value ఎంత రా? 6.67 into 10 to the power minus 11. M1 ఎంత? 6 into 10 to the power 40. 4 into 10 to the power 60 divided by r square. R square అంటే 10 to the power 10 whole square. ఇదే కదా. Yes. So sir, 6.67 into 6 into 4 into 10 to the power 60 plus 40. 40 plus 60 is 100. 100 minus 11 is 89, sir. 89 divided by 10 to the power 10 square into 10 to the power 20. This 20 will be getting subtracted. Now final answer ఏంటంటే 6.67 into 6 into 4 into 10 to the power 89 minus 20 is approximately 69 Newton. చాలా పెద్ద ఫోర్స్ రా. Very understanding? It's a massive force, huge force. అదే now gravity will show all of its colors. అంటే now the doors for time travel will open. ఇప్పుడు the doors for your black holes will be opening. అదే కదా. I hope you are understanding. Yes. చూసుకోండి. Okay. Yes. So just a minute. Yes. So ఇప్పుడు let's talk about, hey, do you want me to talk something extra? No, it's mathematics రా. చూసుకోండి. 10 square is 100, okay, but 10 to the power 10 whole square is not 10 to the power 100. Hey, it's wrong, it's not 100, okay. A to the power b whole to the power c is equals to a to the power b into 0. Indices formula ra. You want me to teach 7th class mathematics? Huh? 7th class mathematics? No. 10 to the power 2 is 100. Can 10 to the power 10 whole to the power 2 is not 10 to the power 100. Eh? Yes. Okay, product of the powers will come into the scenario. Okay, don't get confused. Mathematics. Choose code. So you imagine one thing, okay? Do you know how the black holes are formed? Do you know how the black holes are formed? A black hole usually forms when the star dies. Dies ante enti sir? When it compresses and hey, this is my star, okay? Chala pedda star ra. Mass m is equals to, let us say, 10 to the power 60 kgs, right? Chala pedda star. Now it died ante now it is getting compressed. There is a certain limit ante this is the minimum size. If it crosses this size, automatically it will convert into a black hole. This is the radius, and this radius is known as Schwarzschild's radius. Okay? When a star dies, it converts into black hole. Just remember this. Okay, sir, already we are having a headache. Why are you telling all these things? Okay. Good afternoon. Okay. So let us talk about the vector form of gravitation. Andariki. Okay, vector form of gravitation. Vector form ante entira. You see, I am not going to complicate things too much. Okay, our target is easily learn the things, easily give exam, easily get qualified, become a doctor, do my free treatment. Ade kada? Yes. Sir, why do you want us to be a doctor, sir? Because I want all of you to do my free treatment. Okay? Yes, very good. Gaming journey, very good. When a star dies, there is no energy left in it. Ante all the matter that was there, it will be attracted towards the core of the star. Ante there is no vibrational or rotational energy to the external matter. It will collapse. Good afternoon. Yes. It will collapse. And if its size is shrinking, it crosses a certain limit. That limit is known as Schwarzschild's radius. The formula for the Schwarzschild's radius is 2gm upon c square. If it crosses this radius, it will become a black hole. Ade, not useful for you, ra. All these things do come under astronomy. Okay, చూసుకోండి. Vector form of gravitation అంటే ఏంటి సార్? ఈ వెక్టర్ ఫామ్లో వీఆర్ ఓన్లీ ఇంట్రెస్టెడ్ అబౌట్ ద డైరెక్షన్. ఓకే, ఐఎమ్ నాట్ గోయింగ్ టు కన్ఫ్యూజ్ యూ విత్ ద కాంప్లికేటెడ్ టర్మినాలజీ, కాంప్లికేటెడ్ ఎక్స్ప్రెషన్స్ రా. ఓకే ఓకే, ఎస్ ఎస్. వెక్టర్ ఫార్మ్ ఆఫ్ గ్రావిటేషన్ ఓన్లీ ఫోకసెస్, ఓన్లీ ఎంఫసైజెస్ ఆన్ ద డైరెక్షన్. ఒకసారి మీకు డైరెక్షన్ తెలిస్తే అదే దెర్ ఇస్ నో యూజ్ ఆఫ్ వెక్టర్ ఫార్మ్ ఆఫ్ గ్రావిటేషన్ ఆల్సో. అండర్స్టాండింగ్? చూసుకోండి. If this is my mass m1 లేదా m తీసుకోండి. ఓకే, దిస్ ఈజ్ యువర్ x యాక్సిస్ రా. చూసుకోండి, y యాక్సిస్, x యాక్సిస్, అంతే కదా? ఎస్. దిస్ ఈజ్ యువర్ సెకండ్ మాస్ క్యాపిటల్ M, లేదా యూ ఆల్సో టేక్ ఇట్ యాస్ 2m, లేదా 2m తీసుకోండి. చలో. ఓకే, సో దిస్ ఈజ్ యువర్ x యాక్సిస్, అందరికి x యాక్సిస్, దిస్ ఈజ్ y యాక్సిస్, అంతే కదా? ఎస్. వాట్ ఈస్ ద డిస్టెన్స్ బిట్వీన్ ద టూ మాసెస్ రా? The two masses distance d is equals to, let us say, d only ra, d only. Let us say the distance is d. Cheppandi. Now I am asking about the force on m. Take the question, calculate the force vector on mass m. Second case lo also calculate, cheppandi andariki, also calculate force on 2m mass ra. Cheppandi. When you are talking about mass m, the force is towards the right side. Right side force ante sir direction I cap ade simply sir F is equals to g into m1 into m2 divided by r square. This is a force sir, కానీ డైరెక్షన్ కావాలి కదా? డైరెక్షన్ చూసుకోండి అందరికి. ఇట్స్ ఇన్ ద రైట్ సైడ్ కదా? yes, the force on m is in the right side. So this is my force on mass m, this is the force on mass 2m. ఇదే కదా? రైట్ సైడ్ లో ఉంటే we call it as positive I cap, అదే కదా? yes, positive I cap అంటే it should be this. Similarly, force on mass 2m, చెప్పండి అందరికి. సో ఫోర్స్ ఆన్ మాస్ 2m is equals to same రా, వాల్యూ remains the same. ఓకే, gm1 m2, ఓకే, gm1 m2 divided by d squared, but the direction is reversed కదా? direction is in the left side అంటే it should become minus I cap. అందరికి చూసుకోండి, అందరికి, all of you understand. ఓకే, yes. You should not say east west ra. We have the standard representation for vectors. Use it. They are not for eating, okay? They are for using. ఇప్పుడు వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి రా. g into m into 2m divided by d squared into I cap అంటే 2gm squared upon d squared times of I cap. ఎక్కడ కూడా డైరెక్ట్లీ ఐమ్ రైటింగ్, చూసుకోండి. ఫోర్స్ ఆన్ 2m is equals to 2gm squared divided by d squared into minus I cap. So this is your first force in the right side. This is your second force in the left side. ఈ రెండుని యాడ్ చేసిన తర్వాత what do you think will be the answer రా? If you are talking about f1 bar plus f2 bar, చూసుకోండి, మళ్ళీ చెప్తున్నాను, these two forces f1 bar and f2 bar, they are acting on two different particles. అదే కదా? f1 acting on m, f2 acting on 2m. So when you add the total forces on the total mass, okay, total forces on the total mass, it is 2gm squared upon d squared I cap kada? Yes, plus 2gm squared upon d squared times of minus I cap, ide kada? Yes. So when you add, it becomes 0. ante enti ra? ante enti? What do you mean by this, sir? That means the external force on this system is 0. ante enti ra? Point number 1 చూసుకోండి. I am going into a little depths of it, okay? Point number 1, the forces are equal in magnitude and opposite in direction. Ante when you add the two forces, it gives you zero force. Zero force ante enti sir? Zero force ante when you see the system from a outer perspective, బయటికి perspective నుంచి చూసుకోండి ఈ మొత్తం సిస్టమ్ ని, what do you observe, right? You will observe that, sir, whatever force is there, it is the internal force between these two, sir. They two are fighting, sir. They two are attracting. They two are falling in love. I don't have to do anything. ఎందుకంటే I am the external person ra. They are doing something. Okay, they are doing something. I don't have to do anything. That means, sir, gravitational force is an internal force. Internal force. Internal force. Ade kada? Yes. Biggest statement of the hour. Chuskondi. What is the statement, ra? Point number 1. Nobody is gonna tell you. Okay, number 1 is gravitational force is an internal force. Ade kada? Why are we talking about internal force, sir? Endukante two masses m1, m2 forces f1 bar, f2 bar, f1 bar plus f2 bar is equals to 0. This is the satisfying condition. Kabatti cheptunnanu, the gravitational force is an internal force. Okay, internal force ante in case of gravitation there is no external force, ra. Okay, no external force. Now I want all of you to connect this with another chapter. No external force ante F external equals to 0. Ide kada? F external equals to 0, ra. Are you clicking something? If you have attended all my lectures, you must click one thing, ra. What is that one thing? Cheppandi andariki. If the net external force is 0, only gravity is existing. Ante enti, ra. Ante enti. Ante net external force is 0. Net external force is equals to mass times acceleration of center of mass. Ante when two objects are there under gravity only, their center of mass remains at rest. It will not move. Why, sir? Why, sir? Very good. Siri, very good. Very good. Siri, very good. I was just going to write the same expression. Expression tarvata, I was just going to write whatever you have written. Okay? Yes, very good. You understand one thing. Gravitational force is an internal force. So even if you see, sir, the masses are getting attracted, so center of mass should also move. Ledandi. No. No. Even if the masses are coming towards each other, their center of mass remains at rest. Enduku, sir? Because gravitational force is an internal force. How did we come to know? We added the two forces, it became 0. Kabatti we said that gravity is an internal force. Internal force unte, yes, gaming journey, internal force can never change the center of mass. మీ దగ్గర 2 masses ఉన్నాయి, 3 masses ఉన్నాయి, లేదా 4, whatever amount of masses you have, if they have only internal force of attraction, their center of mass will never ever change. It will always remains the same. అదే కదా? Yes. చూసుకోండి. Next, my next very important statement that Siri has already said. What is the statement, ra? Statement number 2 is chala important, okay? Gravitational force is a central force. Okay, it's a central force. So central force ante enti ra? You understand. If you are good with your center of mass chapter, everything will get much more simplified in gravitation. Central force ante enti ra? Na daggara 2 masses unnai, chuskondi. Mass m, mass m. The distance is d. Ikkada the radius is r1 and here the radius is r2. Cheppandi, what is the gravitational force between these two? Find the gravitational force. So question is, gravitational force is equals to what? Endira. If these are the systems, I want Okay. So the gravitational force between the two objects is given as F is equals to gm1 m2 divided by d squared. Ide kada? Yes. Very good. Very good. Andariki, very good. I am proud of you that you are giving me all the wrong answers. It's wrong. Okay, it's wrong. Why is that? Very good. Very good. Gaming journey. Very good. Okay, very good. Central force ante entira? Central force ante the force always acts between the center of the mass. Center of mass ante enti telusa? When you have a mass, you only consider the center of mass, sir. Ee sphere kosam the center of mass is at the center. Ade kada? Yes. So this is my first center of mass. Ide na second center of mass, and the distance between them should be the distance from their center of masses, not their surfaces ra. Central force kada? Central force unte this should be your total distance. Ide cheppandi. Sir, radius r1 kada, so this distance is r1. This distance is d. Ekkada radius is r2, right? So this distance becomes r2 ra. So mottam distance is r1 plus d plus r2. Are you understanding? So your force should be equals to g m1 m2 divided by d plus r1 plus r2 to the power 2. Ide kada? Yes. 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 Okay, sir. Then why do we take such things? Chuskondi. If this is my first mass, okay? If this is my second mass, distance is r1. Ekkada uchi the distance becomes d, and here the distance becomes r2. Mass is m1, mass is m2. Cheppandi andariki. What is the force ra? Sir, F is equals to g times of m1 times of m2 divided by total distance between their centers. Total distance ante enti ra? Add all the distances. Ante r1 plus d plus r2 whole squared. Sir, are we going to do this all the times? All the times? No. 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 Okay? We will not be writing this all the times. Why, sir? Because we will be considering the distance. Ante enti ra? Distance ante enti? Chuskondi. If at all these radii or the distances is negligible ante enti ra? If this is my first mass, I am lifting it something like this. Should not happen like this, kada? Yes. So this is my first mass. Okay, I am lifting it like this. Chuskondi. Same distances are there, kada? Radius r2. Here the radius is r2, and ekkada uchi the radius is r1 ra. Okay, the distance is d, but I am only considered about these two spheres. Ippudu cheppandi. Radii are same, but the distance became too much. Ade kada? Yes. So now this is the distance ra. Idi mottam distance. In this case, we will not consider their independent radii. We will simply say, sir, if distance is d, F is equals to g times of m1 times of m2 divided by d squared, because distance is too much as compared to that of their radii. Ante kada? Yes. So this, hey, not small ra, not small, not small. Now let us make it small. You want me to? Okay, don't check my ego, ra. Okay, don't check my ego. Okay, if you don't think it is still not small, I will still make it something like this. Okay? Not small, right? Not small, not small. Not small, not small, not small. Ippudu cheppura, not small. Yes. Most of the times, the distances or the radii will be smaller only ra. Ante kada? Ippudu cheppura. Where did you go? Tell me. Are the radii small? Yes, they are small, sir. Very small. As compared to that of the distances. Okay? Yes. Kabatti, you can simply say the force is G m1 m2 divided by d squared. But if the radii are not small, ante this scenario, ee case lo the radii are significantly large kada. So in this case, you can simply say it is equals to total distance. Okay? But if the radii are too small, then you can't say anything. Okay? You can't say. You understanding? Yes. So now let us talk about the superposition of the forces. Superposition ante enti, right? These names are useless. Okay? These names are useless, ra. If you know vector form, if you just know the vector form, ade more than sufficient to solve any problem, ra. Ade kada? Yes. Chuddam. So this is my first mass. Chuskondi. Physics lo you will have point mass, leda you will have continuous mass distribution. Ade kada? What I am telling to you, a mass in physics could either be a point mass. Point mass ante enti ra? Point mass ante you will just take a single point. This is my point mass, this is my point mass. 2 point masses kada. Now calculate the force between them, G m1 m2 by r square. Yes. Yes, Gonat, whenever you are having significant amount of radii, take their center of masses. Are you understanding? Center of masses ante enti ra? If you remember the center of mass chapter, this is my mass m1, this is my mass m2, the distance between the surfaces is d, radii is r1, ekkada vachidi radii is r2. Ippudu chuskondi, I am telling you a whole new way, okay? If you are into much detail, okay? If you are into the details, what did we do, ra? We first found the center of mass. Ade kada? Where is the center of mass, sir? Step number 1, calculate the center of mass. Sir, center of mass is at the center. Ade kada? We found the center of mass. What is the formula? m1 r1 plus m2 r2 plus all these things. For a sphere, the center of mass is at center. Ide kada? Yes. As soon as we calculated the center of mass, what did we do, re? We replaced the entire mass. We replace this entire mass with the center of mass. That is the definition of your center of mass itself. What is the definition, sir? Center of mass is the point at which the entire mass of the object is concentrated. So entire mass m1, it is only confined in this region, ra. Entire mass m2 is only confined in this much region. Distance cheppandi between the two masses, ra. Now this distance will be calculated, counted. This distance will also be counted. And this distance is r1, this distance is d, distance is r2. Are you understanding? You can go in this way also. It simplifies the question by a great extent. Okay? Central force ante enti, sir? Gravitational force usually acts between the center of mass of the objects. Actually, center of the gravity should be there. But yes, very good. Mass is concentrated at a point. So you remove entire shape, take a single point. Remove entire shape, take a single point. Now the distance between the 2 points will matter a lot. Okay, not the distance between the shapes, the distance between their center of masses. Understanding? Yes. So gravitational force is a central force anedi. You can say, sir, gravitational force acts between the center of masses. Center of gravity, actually it should be center of gravity. Kani for symmetric objects, center of gravity and center of mass are the same. For symmetric objects, center of gravity and center of mass are the same. Yes. You remember two things very carefully, okay? First one, gravity is a central force, gravity is an internal force. Internal force unte acceleration of center of mass 0, speed of center of mass 0, position of center of mass remains the same. Ante kada? Yes. Very good. So ante entira, do you want me to take a little more discussion on this? Okay, I will take a little more discussion. Chuskondi. This is my mass m1 andariki. So let us say mass is m. Okay, mass is m ra. Ikkada chudandi. This mass is 6m, all of you. Okay. Radius is r. Ikkada kuda the radius is r. Okay. Let us say the distance between the two is something around 8r. Masses unnai kada. It could be a very good question actually. combining the two chapters, gravity plus center of mass. Gravity plus center of mass, and it has been asked in 2025 paper. I solved that question, okay? If you remember in center of mass chapter, we solved it. We solved it, okay? We solved it. Okay, we solved it. Hey, it's required, right? It's required. The question has been asked in 2025 paper. Choose one. What does the question say? Mudatiga, I want to calculate where these two particles will collide. Ade kada? Distance. Where will these two particles collide? Where will the first and second mass, they are attracted. Why? Because gravity, sir. Gravity. So gravity is attracting, and I want to calculate the position. Don't do anything. Close your eyes. Calculate the center of mass of this object. Here. Ekkada kuda center of mass here. Ide kada? Yes. Dan tarvata replace the entire masses. Until this total mass m was here, now it is concentrated on a single point. Total mass 6m was here. Ante total is 10r kada. G m1 m2 divided by r square. 10r whole square. Ide kada? So this is your gravitational force. Choose. That means 6g m square divided by 100 r square. So this is the force between the two, and I want to calculate the position at which they will hit. Ante kada? Yes. The position at which they will hit. The position at which they will hit ante, sir, gravitational force is an internal force. Kabatti, the center of mass will remain at rest. Ante, center of mass remains at rest ante entira? It will move. Center of mass is still at rest. When they collide, center of mass is still at rest. Ante, collision point lo chuskondi. At the point of collision, the center of mass and the two masses, they are at the same point. Ante entira? They two will collide at their center of mass only. Ippudu cheppandira, center of mass formula enti? Two mass system kada, distance is 10r, sir. So center of mass distance d1 is equals to, sir, m2 total d divided by m1 plus m2. Gurtunda formula, sir? I don't know the formula only, sir. m2 ante 6m. d ante total distance 10r divided by m1 plus m2 ante this will collide at this point. The two masses will collide at this point, and the distance is this much, 60r by 7 from here. Ante 60r by 7. Next chudandi. Okay, I'm not going into much details. Very good. Yes, very good. Superposition of forces ante entira? You can simply say, sir, net force on a given particle. Ippudu superposition lo we are only interested only on the one particle, single particle. Epadaina superposition gurinchi maatladalante, you only see the single particle and write the all forces on that single particle. Ade kada? Yes. So net force is equals to F1 bar plus F2 bar plus F3 bar plus F4 bar plus so on and so forth. Ide kada? But these are added in vector form. Vector form lo add cheyalante em cheyalira? You must remember the formula also. What is the formula, sir? Root of a square plus b square plus 2ab into cos theta. This is the formula that you must understand. Choose kondi. So if I have a mass system placed along the side of an equilateral triangle, andariki equilateral triangle unte, do you remember we did these questions in electrostatics also? Whatever I am taking here, I have already taken in your electrostatics. Okay, I have already taken in your electrostatics. Cheppandi andariki. So if the distance is d, okay, ikkada kuda the distance is d, and here also the distance is d. Mass is m. Mass is m, particle A, particle B, particle C ra. More particles unnai. Mass is m, distance is d. Very good. Parimala, very good. Very good. Question is, find net gravitational force. Find net gravitational force on particle A. Cheppandi. It's a very easy question actually. You must be able to say it. No, 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 Parimala, it should not be f1 square plus f2 square plus f3 square plus, it's wrong. Should be రెండు forces తీసుకోండి. You cannot take all the forces and add all of them in vector form. You can only take 2 forces at max. దాని తర్వాత you can go for third one, then you can add fourth one. Okay? Very good, Siri, very good. Okay, very good. Okay, okay. A good word from one language is the abusive word in another language, okay? Yes. Yes. Very good, very good. Gonan, very good. Okay, very good, very good, very good. Cheppandi. So, when you talk about the forces on a particle A, on particle A ante, particle B is attracting, particle C kuda attracting kada. Yes. So, particle A is attracting ante, this will be your force F. Conditions matrame same untundi. Your distance is same, your masses are same, your angles are same. So, I am naming the two forces to be same also. Okay, if force is F here, the force will be F here also. Ade kada. This is also an attraction force and the value is same. F. Ante kada? Yes. What about angle, sir? What about angle, sir? Equilateral triangle, ra. So every angle becomes 60 degrees. Ade. Now when you calculate the net force, you are doing the superposition of the forces. Same thing, okay? Same thing. So this is particle A. Ide na first force, force F. This is my second force, force F. Angle is theta. Cheppandi sir, net force F is equals to plus theta value intira 60. F1 F2 same. And root F square plus 2 into F into cos in 60. Cos 60 is a half. Idi half and 2 gets cancelled. And root of f square plus f into f. F into f is also f square kada? Yes, 3f square. So root of 3 into f square comes out. Net force is equals to f root 3. Ipudu naku f ki value kavalira. F value ante sir g m1 m2 upon r square. Ade. So net force f net is equals to g into m1 into m2 divided by r square into root 3. Ide kada? So gm square by d square root 3, this is your net force. So I had taken a triangle, you can take a square, then you can take a pentagon, then hexagon and all these things. Okay? Okay? Take this as a homework question. Andariki. So you can take it as a homework question, mass m, homework question, mass m, mass m, mass m. Distance d, distance d, distance d, distance d. Okay, particle A, B, C, D. Force on particle A. Calculate change. Ante kada? Yes. Yes. So now, many students are watching. Yes, very good. Siri, very good. Very good, very good. Okay, your answer is correct. I believe as long as I remember, your answer is correct. ఇప్పుడు చూద్దాం అందరికి. Now, how do you do? Let us talk about cause of gravitational force. చూసుకోండి ఫిజిక్స్లో if you have that curiosity of asking why, మూడు లెటర్స్ ఉన్నాయిరా. I'm not teaching physics to BSc, MSc, PhD students. Okay, therefore all this discussion is just a discussion for you, not much things to understand. చూసుకో sir, gravitation force is there between objects, నాకు తెలుసు, కానీ ఎందుకు, why is gravitation existing? Okay, he is telling space time curvature, okay. Why is gravitational force exerting? We will stay in our limits and we will say, sir, there is some property towards a mass. Okay, there is some property towards a mass. Okay, gaming journey, why does a mass bends the space-time fabric? That's a question. This series never ends, okay. If you keep on asking why, you will end up winning a Nobel Prize in physics, okay. You will end up winning a Nobel Prize in physics. But we don't want a Nobel Prize in physics, we want a seat in MBBS college, okay. So, we don't ask why, okay, we just ask how. How to solve the question, sir? How to understand the force, sir? Okay, Einstein died, so you don't know. చూసుకోండి, if I have a single mass, let us say mass m, అదే కదా, near this mass I am placing another mass, let us say mass is m0. m0 అంటే చిన్న మాస్, స్మాల్ మాస్, టెస్ట్ మాస్ అంటారు, okay. What will happen, sir? This bigger mass will attract it very easily, అదే కదా. It will attract, అదే. Do you remember the story I told in electrostatics? Do you remember something? What did I say? There were three people, I don't remember the names, okay. This was a first person. Okay, this was a first person. What name should I take? Okay. What name should I take? Let us say this name is Manishra. Okay. And this is another person. His name is Girish. Okay. Anyone Manish and Girish in the class? I'm sorry. Anyone Manish and Girish watching? I'm sorry. So this Girish is watching Manish and giving him smiles. Okay. Okay. This Girish is watching Manish and giving him smiles. What will happen? Time to time, consistently 2-3 hours have been gone, and Vadu is just watching at Manish and giving him smiles, rather. Okay. What will happen, sir? Manish will get uncomfortable. కొంచెం సమయం తర్వాత, this entire fellow, what did he do is, he is slowly coming to Manish, giving him smiles and slowly coming to Manish. What will happen, Manish will get angry, Hey, have you gone mad, rascal? He will push him, kick him, throw him away. Don't come, don't come to me. Why are you coming to me? But in case lo, Manish is not resisting the change, okay. But in this case, Manish is liking. So Manish also moves towards the right. 2 kadam tum chalo, 2 kadam hum chale. Okay? Yes. So this is your gravitational force, ante they are just attracting one another, ante kada. Now Manish held Girish and hugged him as a brother, okay? Okay? Yes, mutual attraction. Ade. The same thing is happening, Okay, the same thing is happening here also in case of masses. They are attracting one another. Okay, Manish attracts Girish with its hands. No repulsion in gravitation. You take whatever you want, there is no repulsion in gravitation. Okay, no repulsion at all. Why, sir? Why no repulsion? Because it is nature. It has been decided by the nature itself that masses will not repel. Charges may repel, attract also. Yes. So mass capital M is attracting ante he is having some influence kada. Yes. So if you put another mass here, it will attract. If you put another mass here, it will attract. Another mass here, attract. Another mass here, attract. It will put another mass here, you will attract. You will put another mass, attract. Another mass, attract. Ade kada. Yes. Ante this mass has his hands ra. He hands tone he is attracting every mass towards himself. Ade kada. This hand is known as, these hands are known as the fields. Invisible hands kada. Yes, invisible hands. Choose kondi. The hands of a mass is known as fields. Okay, fields. We are not talking about root 4. Parimala, what are you talking about? No, we are not talking about V and omega. It's just the beginning of the chapter, right? Why would I talk about all these things? Hi. Soulmate, hi. You understand, Ra? If at all there is a mass, that mass creates an invisible field. And your body, your entire body is also creating some field around yourself. But that field is very small, chala chinnara. That's why you can't feel the experience or you can't feel that field. Okay? But you understand, every mass in this universe, mass ante it is a chair, ball, football, your pyramids, your body, your mobile, laptop, notebooks, pen, pencil, your hands, everything. Mass kada, each and every mass is creating some influence around yourself. But you can't see it, Ra. You can't see it. Okay, you can't see it. Dayam, sir. No, you can't see it. Okay, you can't see it. But there is a field ante influence, influence ante hands of a mass. With those hands only, it is attracting another mass. So that is known as gravitational fields. Fields ante enti ra? Cause of gravitational force, we don't know. To be simplified, we don't know the cause. Why the masses attract? We don't. And there is an explanation that space-time fabric is there. Why the space-time fabric bends? We don't know. We don't know. Okay, we don't know. But what we say is, we defined a new terminology and we say that to be the gravitational field. Andariki chuskondi. We say that gravitational field is the effect or the influence around a mass. Okay, electrostatic field unte influence around the charge, gravitational field unte influence around a mass. Ade understanding? Yes. So this is known as your gravitational field. You understand about the gravitational field now. So we are talking about the gravitational field. I have two fields. First field is your mathematical field. Andariki chuskondi. So first we will discuss this gravitational field from a mathematical perspective. Okay. Then we will discuss it by your geometrical perspective. Mathematical, geometrical, same kada sir? Yes. Visual field. Okay. Visual perspective. Okay, mathematical perspective and visual perspective. Mathematical perspective lo, yes, very good. Rupesh gaming journey, very good. The area under, you cannot say area, you should say region. The region under the influential force of gravitation is called as the gravitational field. Okay, yes. Chuskondi. Let us say this is my mass M. Hey, all of you. If you bring another mass M here, it will not attract. Enduku sir? Because it is too away. It is not in the range. Okay, it is not in the range. Okay, sorry, you shift this mass M and you move it in the range of it. Ante entira. So this is your mass m kada. Yes. You slowly move it. Now it is in the range of this force. Range ante field. Range ante field. Ide kada. So okasari it's in the range. Now it will get attracted. Now it will get attracted. Ide kada. Yes. Attracted. This is known as gravitational field. Field ante range ra. Range of force. Ade. So if it is in the field ante it is into the range. Ante the gravitational force will work. If it is not in the range ante it's out of the field. No gravitational force. Ardhamaindi andariki? Yes. Chuskondi. Mathematical description of field ante entira? Na daggara rendu masses unnai. Chuskondi andariki. This mass is m1, this mass is m2 andariki. All of you, it's a very important discussion, okay? The distance between the two masses is given as r. Ippudu cheppandi ra, forces cheppandi. Two forces unnai kada, rendu forces unnai. The first force is on the first particle on mass m1, force is force on m1. Ekkada vachi on the second particle I will call it as force on m2. Ide kada. Fm1 ante force on m1, Fm2 ante force on m2 ra. Ide kada. Yes. So here you talk about the force on m1. Sir, value enti? Sir, value is g times m1 times m2 divided by r squared. Ade. Are you understanding? Yes. What about force on m2 ra? Ade same force. Force does not change. G times m1 times m2 divided by r squared. Force will not change. Ide force on m1. And that is the force on m2. Ante kada? Yes. Force on m1 and force on m2 ra. Ippudu I am interested to talk about field. Usually you represent the field with the letter E. E ante field. Electrostatics lo E ante electric field. Gravitation lo field ante gravitational field. Okay. So I am talking about two different fields. Andariki chuskondi. Field due to mass m1. Fm1 ante force on mass m1. Okay. Em1 ante field due to m1. You understand the chinna terminologies ra? Chala important. Okay. Em1 ante field of m1 leda field due to m1. Are you understanding? Yes. Sir, what is the field due to m1? You take force on m1 and you divide it with the mass. What mass ra? Force on m1 divided by m2. So sir, electric field due to first mass equals to force on first mass divided by second mass. Yes. This is how it is. It is how it is ra. ఎక్కడ కూడా చెప్పండి రా. ఫీల్డ్ డ్యూ టు మాస్ m2 ఈక్వల్స్ టు ఫోర్స్ ఆన్ మాస్ m2 డివైడెడ్ బై మాస్ m1. అదే. ఆర్ యు అండర్స్టాండింగ్? ఎస్. వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి రా. ఫోర్స్ ఆన్ మాస్ m2 అంటే ఏంటిరా? gm1 m2 by r square divided by m1. ఇదే కదా. m1 gone. What is left రా? Field due to m2 is equals to gm2 by r squared. చూసుకోండి. And here field due to m1 is equals to gm1 divided by r squared. Simple, very easy, very smart. Are you understanding? Your field is not simply equals to force by mass. This is not an inclusive statement ra. Meeku teliyadu field due to which mass, force on which mass, and what mass is the denominator mass m. Chuskondi. This is the very inclusive statement I am writing. It includes everything. Are you understanding? Rendu masses unte you can simply say forces are equal ra. No problem in that. But field due to first mass equals to force on first mass divided by second mass. Ikkada kuda field due to second mass is equals to force on second mass divided by first mass. Are you understanding? Yes, very good. Visual effect ante entira? Field ante it's a set of lines. Okay. Your gravitational field for your masses na daggara mass m unte your field is a set of lines. We usually represent that with a set of lines, and in gravitation we call it as field lines, and for any mass ra, ఏదైనా mass తీసుకోండి, the field lines, they are always directed towards the mass. Understanding? Yes. Okay? Field lines, they are always directed towards the mass. Sir, positive mass, negative mass unda sir? No. Electrostatics lo positive charge unte field lines away from the charge, negative charge unte field lines towards the charge. Kani gravitation lo there is nothing like this. Okate condition untundi. Yes, Gonot, you can write G as E, G is equals to E. Kani, this is only valid for the planets. Okay? If you are talking about field due to any planet, E mass, if it's a planet, then we can replace this E with a G symbol. Okay? Planet ante, we live on a planet kada. We do some science experiments, we send the space shuttles into the sphere, atmosphere, all these things. We need this field value constantly ra. Kabatti we simply say, sir, it is equals to G. Are you understanding? Because we live on a planet. We can write it. For a planet, you can say G is equals to E. Very simple expression, okay? Oka planet kosam G is equals to E. E ante enti sir? Gravitational field. G ante enti sir? Acceleration due to gravity. Are both the same? Yes, they are both the same. But it must be a planet, okay? It must be a planet. Planet ante enti sir? This is my first brick, sir. Mass is M, and let us say the field is E. Can I say E is equals to G? No, you can't say. G is only defined for planets, not for any other shapes. Okay? Yes. Even if it's a sphere, you cannot say G. It must be a planet or it must be a star. Okay? Very good. Good. Now, let us talk about field due to a point mass. Field due to a point mass. Sir, ela ravali sir? If only you have a point mass, you remember this, okay? I will compare side by side, kani I want all of you to understand the situation also. Na daggara rendu masses unte, let us say the mass is m1, ee case lo the mass is m2, ide kada, and let us say the distance between the two is r. Chappo, what did I say? Sir, field due to mass m1 is equals to force on mass m1 divided by mass m2 ra. Chuskondi. Ide kada? Yes. But it is only valid when you have two mass systems. Okay? Rendu mass systems undalira. Substitute the force, sir, G m1 m2 divided by r square divided by m2. Ide kada? Yes. So m2 gone. So field due to mass m1. R and enti ra? R is the distance at which you are interested to find the field. Point mass ante okate mass unte, let us say your mass is m and you want the field somewhere here. You always understand when we talk about field, we talk about field due to a mass at a given distance. Two things. Rendu things unnayira. First thing, field due to a mass. Okay, this is a very important condition. Second one is field at a distance. Chala important things. You can change whatever you want. You can change the mass also, make it bigger, make it smaller. Pedda chinna, you can do it. And at the same time, distance also you can shift it. Distance ante entira. I want the field at this point kada. You can move this point anywhere into the space, wherever you want. Are you understanding? You can move the distance also, you can change the mass also. Okay? You can change the distance also, you can change the mass also. Kani okkasari na daggara distance and mass ki values unte, you must say, sir, E is equals to gm upon r squared. Ade. It's a value ra, but. Important point. Gravitational field is a vector quantity. Vector quantity ante enti sir? Vector quantity ante it has magnitude and as well as the direction. Andariki chuskondi. So sir, if I have a point mass m, I want the field at certain distances. Okay, yes. Sir, this distance is r1, this distance is r2, ekkada vachi distance is r3, distance is r4, here the distance is r5, and here the distance is r6. Fields cheppandi andariki. Fields ante magnitude also and direction also ra. So ee point lo vachi your field E is equals to gm by r1 square ide kada, and this is the direction. This is the direction. Cheppandi here gm divided by r6 whole square. What about direction, sir? Towards the mass, towards the mass. Here tell me, sir, gm divided by r5 whole square ide kada. What is the direction, sir? Towards the mass. Always remember, always. Here tell me, field, sir. Sir, field is equals to gm divided by r4 square. Chudandi, your mass is same but fields are different. Enduku, sir? Because the distances are different. Okay? Yes, very good. Okay? Yes. So here you can simply say, sir, field is equals to gm divided by r3 square, and this is your direction. Direction kuda matters ra. This is the direction, gm divided by r2 square. Ante kada. If you are talking about circle ra, circle ante enti, sir? If this is my mass, and this is your circle ray. Okay, your circle ante enti ra? Every point has the same distance, ade kada? Yes. So at each and every point, let us say the radius is r, all of you. The radius of this circle is r. At each and every point, the value of the field is same ra, andariki. What is the value, sir? Gm by r square, 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 gm by r square. At each and every point, field is gm by r square. Kani direction is different. Are you understanding? These are the directions. These are the directions of fields, but value is the same. Okay? Value is the same. Good. Ippudu, let us take a question. Okay? చెప్పండి. లేదంటే you take the same values ra. Okay, you take 16 meter here also, because 40 will not give you the proper answers. It will get complicated. Yeah, ask Maitri, what is your question? What is your question, Maitri? Feel free to ask. No, Kepler's laws are at the end. Rupesh gaming journey. The Kepler's law will start around 6 p.m. Okay, 5:30 p.m. What is the time now? 3:30 p.m. 2 hours are left. Class duration will be till 6 p.m. Ra. And immediately we will have another session also, electromagnetic induction at 6:30. So the class will be there till 10 p.m. Okay, till 10 p.m. Okay. Time period of a geostationary satellite is 24 hours at a height of 6 RE. Okay. From the surface of Earth, the time period of another satellite whose height is 2.5 RE from the sun. We will do it. Okay, we will do it. I want to teach you everything about the satellites, orbital speed, time period, everything. We will discuss that. We will discuss it here only, because if I solve it here, most of the students might not understand what formula I am using. Okay, I can't do anything in that, Surya. If ads are coming, what can I do in it? Okay, Cheppo. Okay, tell me, Ray. Let us talk about fields now. Okay, and I will take your question, Maitri. Keep this question aside. Yeah. Maitri, we'll do it. No problem. Okay, we'll do it. Immediately, as soon as I start the orbital speed, motion of satellites, how much time is left? You see, whatever topics do I have to teach now? Just a minute. Gravitational field, then the gravitational potential, potential energy, then motion of satellites. Okay, and then we will take a break. Motion of satellites ante, after I solve your question, we will take a break. Let us talk about potential, all of you. So when you are talking about potential, field kada, yes. Field lines due to a mass are always directed towards the mass itself. Ade kada, yes. Cheppandi. So field due to mass 2m is directed towards the 2m mass. Ide kada? Yes. So field due to mass 2m. Field due to mass m is also directed towards the mass m itself. Kada? So field due to mass m. What about angles, sir? What about angles, sir? Chusko. If you are able to understand, it's a 3, 4, 5 triangle, ra. Okay, it's a 3, 4, 5, 3 meters, 4 meter, 5 meter inte. This angle automatically becomes 53 degree. And this automatically becomes 37 degree. If you know it, well and good. If you don't know it, I will give you the values. Choose kondi. Join it. Triangle formed. Ade kada? Yes. Ippudu this angle should be equals to 53. Ide kuda 53 ra. Ante. So sir, total angle becomes 106. Ide kada? నాకు cos 106 కావాలిరా. You must know trigonometry. Cos 106 అంటే cos of 2 times 53 ఇదే కదా. Yes. Cos 2 theta ఫార్ములా ఏంటిరా? 2 cos square theta minus 1 అంటే 2 into cos square theta cos 53 చెప్పండి. cos square 53 అంటే ఏంటిరా? cos square 53 అంటే it should be 3/5 whole square minus 1. So 2 into 9/25 minus 1, 18/25 minus 1 అంటే minus 7/25. Okay, this is cos 106. Cos 106, cos of 106 is equals to minus 7/25. Use it. We will use it. Okay, we will use it. చెప్పండి. Formula, this field is E. This is also E kada. Yes, చెప్పండి. So net field E is equals to root of E1 square plus E2 square plus 2 into E1 into E2 into cos of theta. Cos theta అంటే cos 106 ఇదే కదా. Yes. Root of E square plus E square plus 2 into E square into minus 7/25 అందరికి చెప్పండి. So when you simplify it, root of, you take E square common ra, and I am taking it out. E square common ఉంటే 1 plus 1 minus 2 times 7/25 అంటే minus 14/25 ఇదే. So E into root of 2 minus 14/25 అంతే కదా. So E into root of 50 minus 14 ఎంత ఎంతారా? 50 minus 14 is 36 divided by 25. Oh, what a perfect values ra. 6/5 E. So this is your net field ra. Okay, 50 minus 14 is 36 kada. Yes. Okay. E value ఎంత sir? E is gm by r square. This is 16, this is 9. Pythagoras use చేయండి రా. This automatically comes to be 25 meters. So E is equals to g into m divided by r square అంటే 25 square అంటే 625. Hey. Should not be. If it's 16 and 9, hey, everything is getting wrong, Ray. Hey, you change the values, okay? It should not be 9 meters, okay? It should be 3 meters, it should be 4 meters, it should be 4 meters. I was in little different thought. It should be 3 meters, idi kuda 4 meters, and this also 4 meters. Now everything sets up, okay? Gm by 3 square plus 4 square ante 5 square, this square will be 25. Gm by 25. So E net is equals to Gm divided by 25 into 6/5 ante 6Gm divided by 125. This is your final answer, okay? If you are understanding, well and good. If you are not understanding, yes, too lengthy, little lengthy, it's little lengthy, but you have to do it, okay? Whoever did not understand the question, please go back, rewind again 2 times speed, and then come to the original part. Okay, yes. Chuskondi. We are done with the gravitational field. We are done with the gravitational force also. Gravitational field is a vector quantity directed towards the mass itself. Okay, field lines gurinchi chuskondi. Hey, let us talk about field lines ra. Same properties as the electric field lines. Okay, properties of gravitational field ra cheppandi. Property number 1, field lines, gravitational field lines, okay, are directed towards the mass. Ante kada. Yes. Point number 1. దాని తర్వాత field lines do not intersect. Number 3rd, okay, number 3. What is it? Field intensity is given by number of field lines. Ante if the field lines are more, intensity is more. Field lines are less, intensity is less. Ade kada? Yes. So this was all about your gravitational field. Okay, ippudu just a minute, okay, just give me a minute. Hello. Hi sir. I'm in the class itself. Okay, sorry. So, okay, yeah. So we are done with your gravitational field. Okay, you are done with your gravitational. I had to talk about gravitational potential. Kani, there is one more important thing that I did not take and I want to take. It is చాలా important topic ra. Okay, very important. Yes. Okay. So sir, acceleration due to gravity ante enti ra? Acceleration due to gravity is nothing but the gravitational field only. Acceleration due to gravity is nothing but gravitational field only. But it is defined only for planets. Defined only for planets. Ade, okay? Acceleration due to gravity is gravitational field only, gravitational field only, but defined for planets. లేదా sun also ra. Planets and sun అంటే systems. Okay, stationary, geostationary systems. Yes. Parimala we will see everything. Okay, we will see polar to equator. We will see with variation with respect to height, with respect to depth on the surface. Everything we have to do. Okay, Mohan Krishna. Okay, that's interesting to know. Right? Okay, acceleration due to gravity is nothing but gravitational field only, but used for planets. Okay. చూసుకోండి. So if at all you have a planet అంటే let us say this planet is our mother planet only ra. What is the name of our planet ra? What is the name of our planet? I don't know. What is the mass of our planet? You must know this. Okay, you must know these values. Mass of the earth. If you don't know, you'll be gone. Okay, you'll be gone. Understand? You must know the mass of earth. Cheppandi, how many of you know the mass of earth re? Huh? How many of you know the mass of earth? So sir, cheppandi. What are you saying re? చెప్పండి అందరికి. సో when you talk about this is earth కదా, this is earth రే, mass is capital M. Okay, capital M అంటే mass of earth, me. How many of you know mass of earth ra? You must remember, there is no other option. You must remember mass of sun. Okay, it is specifically expected. Remember what? Remember mass of earth. ఎందుకంటే there was a direct question in NEET in which it asked about mass of sun. అదే. Okay, yes, good. Madhukshara, very good. No. Parimala, that is the value of acceleration due to gravity. We are not interested in that. Mass of earth. You must remember, okay, mass of earth. I don't know. Similarly, you must remember mass of sun ra. Sir, you are our teacher, sir. You don't know mass of earth? Yes, because I don't want to give NEET. You want to give NEET? Okay? I don't want to remember it. I can search it on Google, but you can't search it, right? You are in the examination hall. Imagine you are in the examination hall, opening Google, searching mass of earth, an examiner watching you from behind. Okay? That happens with you only, not with me. Okay? You remember it, right? Remember it. సో సార్ ఇఫ్ మాస్ ఆఫ్ అర్త్ ఇస్ దిస్, ఇదే నా డిస్టెన్స్ రా ఆర్. చెప్పండి వాట్ ఈస్ ద ఫార్ములా ఫర్ ఫీల్డ్ రే? పాయింట్ మాస్ కన్సిడర్ చేసుకోండి. ఈ మొత్తం ప్లానెట్ని యూ అజ్యూమ్ ఇట్ యాజ్ అ పాయింట్ మాస్. ఓకే, ఎస్ ఎస్. సో పాయింట్ మాస్ ఉంటే ఫీల్డ్ ఈజ్ ఈక్వల్స్ టు gm/r². ఇదే కదా. ఎస్, ఫీల్డ్ ఈజ్ నథింగ్ బట్ యువర్ యాక్సిలరేషన్ డ్యూ టు గ్రావిటీ. చూసుకోండిరా. బట్ 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 what did I say? What did I say? Your field is dependent on two different factors ra. Chusko, where were we talking about it re? Where did it go re? Here. Your field is dependent on two things ra. First one is your mass. Mass change chesi, field also changes. Similarly, your distance ra. Okay? Similarly, you must know the distance. Distance ante enti sir, at what point you are interested. I am going to take both the variables and we are going to discuss both the things. So I have taken both the variables and I am throwing it right here. Choose kondi. Here. So sir, first is your distance, second is your mass. Can we change both? Yes, we can. Okay, we can change everything. చూసుకోండి. సో వీఆర్ టాకింగ్ స్పెసిఫికలీ అబౌట్ యాక్సిలరేషన్ డ్యూ టు గ్రావిటీ g. సార్ ఫార్ములా ఏంటి సార్? నా దగ్గర ఒక ప్లానెట్ ఉంటే మాస్ ఇస్ క్యాపిటల్ M అండ్ ఐ వాంట్ ద వాల్యూ అట్ సమ్ డిస్టెన్స్ r రా. r అంటే లెట్ us say స్మాల్ r. ఓకే, బికాస్ క్యాపిటల్ R ఇస్ ద స్పెషల్ నేమ్ వీ హ్యావ్ రిజర్వ్డ్ ఫార్ ద రేడియస్. ఓకే, క్యాపిటల్ R అంటే రేడియస్ r, స్మాల్ r అంటే ర్యాండమ్ డిస్టెన్స్. ఇప్పుడు చెప్పండి అందరికి. So when I am talking about acceleration due to gravity at this point, cheppo, what is the formula, sir? Formula is electric field, gravitational field only. gm/r². Gravitational field, gm/r². Gravitational field. Andariki. This is your acceleration due to gravity. Where, sir? Ikkada? At a point that is outside of the planet. Ante kada, this is your planet, this is the external point. Okay, sir. Naku ardhamaindi. But I want to find the gravitational field at this point ra. Cheppu. So sir, E at this point ante G kada. E is equals to G only. But gm/r². Ade. Now my question, yes. We live on the surface of the planet, sir. Radius of the earth is approximately equals to, cheppandi, radius of the earth is 6,400 kilometers. So if you are talking about planet, objects, aeroplanes, birds, human beings, animals, trains, buses and all this stuff, your height or your distance, it will be r only. Okay, your distance will be r only. But when you are talking about moon, when you are talking about sun, then they are far away from the surface. Ide kada. So you must differentiate what value to take. Okay. So on the surface of earth, this is your g value. Substitute cheskondira. G is equals to gm/r² kada. Yes. G value enta sir? 6.67 into 10 to the power minus 11. Mass of earth enta ra? Mass of earth is 1.9 into 10 to the 5.9 into 10 to the power 24. Approximately 6 into 10 to the power 24. Okay, I know it actually. I know it, but I said I don't know it. Okay, I said I don't know it just to make sure that you know it. I know the mass of earth. 6 into 10 to the power 24 kg. Okay, divided by r² is 6,400 kilometers ante 123 meters ra, meters squared. Simplify cheskondi, your answer is approximately 9.8 meter per second squared. Leda, you can also approximate equals to, ante kada, this is the value of your g. Okay sir, okay, ardhamaindi. So ippudu let us say this is my earth ra. Okay, let me just leave a little space. This is my earth. Okay, this is my earth. Mass is capital M ra. Radius is capital R. Ante kada, this is your earth. And here is me. Standing. Okay? Standing is me. Me. Mass enta sir? Mass is small m ra. Small m is the mass. Cheppu. What is the gravitational force between us, sir? Gm1 m2 by r square. Ide kada? Gm1 m2 by r square. So force is equals to Gm1 m2 by r square. Direction cheppura. Force on me. On me. On me kada. I'm talking about force on me. So when I'm talking about force on me, it is directed towards the center of the earth. Enduku sir? Enduku center sir? Because gravitational force is a central force. Okay? Gravitational force is a central force. Central force unte directed always towards the center. You understand this quantity ra? Small g. Small g kada? Not downwards. Hey, it should not be downwards. It should be towards the center of the earth. Hey, if I'm here, American here is here. Hey, this is American people. They are also acting downwards. Not downwards. Everywhere the force is, here is Somalia. Okay, Somalia. Their force is here. Sir, why they are not falling down, sir? Huh? Sir, why they are not falling down, sir? I hope you are understanding it, okay? If the person is here, the gravitational force will be here. Something like this. Towards the center. Always towards the center. Gm by r square is g ra. M ante mass of the person, not mass of the earth. Mass of the person. So this is a force. Ante F is equals to m into g. So if at all you are standing on the earth here, mg will be downwards ra. If you are standing here, paina kya chestunnaru ra? Mg is in the upward direction. If you are standing here, mg will be here. If you are standing here, mg will be here. Always towards the center. Understand this situation, okay? Towards the center. Towards the center. Towards the center. Yes, due to gravitation. Okay. All right. All right. All right. Ippudu, let us talk about variation. చూసుకోండిరా. The first variation is at heights. Heights అంటే distance increasing. లేదా at depth. Depth అంటే ఏంటిరా? You dig the surface. Third one, on surface. On surface మీకు తెలుసురా వాల్యూ, అదే కదా. Fourth one, at equator. Fifth one at poles. Sixth one due to Earth's rotation. So these are the 6 factors you have to study. All 6 of them, they affect the value of acceleration due to gravity. Ante indirectly they will affect the weight of a person. These are the 6 factors, okay? Andarki chuskondi. These are the 6 factors that would be exclusively affecting the value of acceleration due to gravity. Ade kada? Yes. Very good. So let us see one by one ra. Number 1. Variation of acceleration due to gravity with respect to heights. These are all the formulas I want you to remember. Okay, these are the formulas I want you to remember. If you don't understand the proof, no matter, it's perfectly all right for me. Kani formulas matrame gurtundale. Formulas are the most important stuffs. Chuskora. So if this is my gravitational planet, Earth ra, Earth. So idena Earth. Okay, for example, I'm telling you, and this is me re. On the planet of the earth, surface of the earth, okay, this is me on the surface of earth. Cheppandi, what is the formula for g? G is equals to, sir, gm divided by r square. Ide kada? Yes, this is the value of g at the surface. This is the value of g at the surface of the earth. Gm by r square. R into radius of the earth ra. But, the same process, the same value, I want it at some height h ra. Chooskondi. So, ide radius is r and at some height h ra, naku ee point pai acceleration due to gravity kavali. Tell me, sir, simple formula, sir, g is equals to gm divided by total distance ra. Total distance ante enti? Ide r, ide h ante total distance r plus h. Total distance is r plus h. Sir, r plus h whole square. Ade. This is your acceleration due to gravity at a height. Are you understanding? Sir, I know the value of it, sir. Sir, it is equals to 9.8 meter per second squared. I know. How will I calculate this? How will I calculate this? Are you understanding? How will I calculate this, ra? To calculate it, you simplify. Ela simplify cheyali, sir. Gm by, you take r common. Okay, this is some mathematical simplifications. Common teesina tarvata 1 plus h by r whole square ra. Ide. You understanding? So when you take it out common, sir, this is acceleration due to gravity. G 9.8. Yes, yes. So sir, g at height h is equals to, you can remember the formula now. Here is the formula andariki. G at height h is equals to original g ante 9.8 divided by 1 plus h by r to the power 2. Understanding? This is the formula. Yes. Yes, yes, yes. So, what is the value of h, sir? Hey, you understand, okay? If it is telling, sir, the radius is 6,400 kilometers. Understand? You must also understand the approximations, when to take this formula, when to take not formula, everything. You understand? If your height is simply equals to 1 kilometer, hey, have you gone mad, ra? You cannot take 1 kilometer. Ante enti ra? Your planet is this. Radius is 6,400 kilometers and meeku 1 kilometer ante somewhere here only, ra. You ignore that 1 kilometer, 2 kilometer, 5 kilometer, 10 kilometer, 20 kilometer, 50 kilometers. You can ignore till 50 kilometers. Dan tarvata, if it is saying 100 kilometers, 200, 400, 1000, 6000, 10,000 kilometers, then you have to use this formula. Are you understanding? Are you understanding? If your h is 1 kilometer, don't use it. If h is 1 kilometer, use the same formula. Okay? Endukante your 1 by 6,400 negligible. Okay? Height is 1 kilometer, use the same formula. Chooskondi. Let us talk about a PYQ. Ra. Is there any PYQ of it? Let me see it. Okay? $2025 only, ra. Last year question, okay? తీసుకోండి. Direct formula based question ra. Okay, this is a formula for a height. Okay, this is formula for height. To everyone who has not registered for YSAT yet, okay, Vedantu All India Score Accelerator Test Series ra andariki. Everybody who has not registered for this YSAT test, let me just tell you that this test started on 4th of January. The second paper was supposed to happen on 11th of January. దాని తర్వాత the third test is supposed to happen on 18th of January. ఎప్పటిదాకా you have missed these 2 sessions, but you have still one more try valid left. Okay, 18th January sessions ki you all register for yourself. Andariki you register for yourself. The link is in the description. Okay, the link is in the description. This is a very important initiative. You can understand your level. I request everybody, just for the namesake purpose, you sit and attend this exam. Okay, you will automatically come to know much more things about it. So ఎవరైనా who has not registered for this YSAT test, you register yourself. ఎందుకంటే 18th January is the last paper that you will be attempting. Okay, even along with that you are getting some resources ra. You are getting some free resources. Okay, you are getting some free resources along with that. All of you is along with this YSAT test, in the description section, in the description, what is it? In the description section of this video, మీకు some test series ఉన్నాయరా, చూసుకోండి. There are some test series including your biology, your physics and your chemistry. You click on them. If you have not registered for the Vedantu website, you register yourself and then you access all these test series. Okay, everything is free of cost. Okay, remember, one last test is left for everybody who has already attended these test series. Very welcome to you. I think you have understood, but don't let your confidence go extremely high if you are having good score, extremely low if you are having a bad score. Okay, be in the moderate level. Confidence is the key ra. And after that you attend the test series that are there in the description section of this video. Okay, yes, do it. I will be back in 5 minutes. Okay students, we will have a break at 4:15. Okay, yes, very good, Gonat, very good. The break is at 4:15. After solving this question we will be having a break. Okay. Done. చెప్పండి. So, hey, what is the question? 48 Newton on the surface of Earth. ఇదే కదా 48 Newton అంటే your weight అంటే mg ఇదే కదా. Yes. So sir, mass times g on the surface of Earth is equals to 48. నాకు mass times g at a height h కావాలి ఇదే కదా. mm gone రా, mm gone. So what do you have? Sir, g of surface divided by g of h is equals to 48 by what? నాకు ఈ వాల్యూ కావాలి ఇదే కదా. క్వశ్చన్ మార్క్. టేక్ ద రివర్స్ రా, టేక్ ద రివర్స్. Sir, g at h divided by g at surface is equals to, let us say, x by 48 అందరికి. So what can you say, sir? G at h is equals to g on the surface into x divided by 48 ఇదే కదా. Yes, you can say that. Yes. Okay. What is the formula for g at height h, ra? What is the formula for g at height h, sir? Sir, g at height h is equals to g divided by 1 plus h by r whole square. Adhe ide kada. Yes. You substitute and you equate with it, you will get the value of x. Naku x kavali ide kada. I just want the value of x ra. Ide you equate and substitute re cheppandi andariki. So I am equating the two. Sir, g divided by 1 plus h ante enti ra? H height at 1/3 of its radius ante h is r by 3 sir. So r by 3 by r whole square is equals to g into x divided by 48 ide kada. Yes. So ikkada nunchi g kuda gone re ante kada. Yes. R is also gone, sir. What you are left with now is, where should I write re? Hey, it's too much confusion. Hey, let us write here. Okay. What you are left with now, 1 plus 1 by 3 is 4 by 3. 4 by 3 whole square is 16 by 9 should be equals to your g by 48. ఇదే కదా. రివర్స్ చేసుకోండి. So 9 by 16 is equals to x by 48. అంటే 16 ones are 16, 16 3s are 48, multiply 9 into 3 becomes 27 is equals to x. అదే. Okay. Next. So let us talk about your variation with depth. Okay, the second one is variation. Hey, let us write the formulas here. Okay, let us write the formulas. All the formulas for your g ra. Formulas list. Number 1, g at height h ra is equals to g by 1 plus h by r to the power 2. Let us talk about g at depth. Okay. G at depth d. Depth d ante telusa. It's a little complicated, but I want you to understand. Okay, very good. Option B is correct. Right. G at depth ante enti ra? This is my planet ra. Chuskondi. Ide na planet. And depth is this much. D is the depth. Ante kada? Yes. So sir, can I say that at the depth d there is one other sphere, something like this? So this is the internal sphere, this is the external sphere. You choose one. The field inside a sphere is 0. Field inside the shell or the sphere is 0 ra. Ante this external sphere is not contributing in the field. Ade kada. Only the internal sphere is contributing in the field ra. Formula enti, sir? You write this distance now. If this is d, total r, so this distance is r minus d. Ide kada? Yes. You write the field now, sir. Field is equals to g into m upon d squared. Ide d squared ante r squared ra. R. For this planet I am writing this part, this internal sphere ra. This internal sphere kosam rastunnaru chuskondi. Gm divided by r minus d whole squared. Ide kada? Yes. This is your field. Gm by r minus d whole square. What is d, sir? D is depth. What is r, sir? R is the radius. Ante kada. Ippudu naku m mass kavali ra. Mass enti ra? Mass of this sphere. Chuskondi. Sir, total mass of the earth when radius was r, mass was capital M. but the mass is distributed on the volume ra. Volume ante sir, when the volume was 4 by 3 pi r cube, the mass was capital M. When the volume is this much ante enti ra, r minus d whole cube kada. Yes, so when the volume is 4 by 3 pi r minus d whole cube, what is the mass? Kavali, take the ratio. 4 by 3 pi gone. What you are left, Ray? Sir, r by r minus d whole cube, not whole cube, something like this. Whole cube should be equals to capital M by small m. Small m kada? Reverse. Sir, small m by capital M. Whole cube. Ade. Sir, ekkada nunchi small m is equals to r minus d divided by r whole cube into capital M. You shift. Chappora. A is equals to g kada. Acceleration due to gravity at depth. G into r minus d divided by r whole cube divided by r minus d whole square. This square, cube, gone. What you are left with? Chappandi andariki. What you are left with is, sir, it is equals to g at depth d is equals to g capital M r minus d divided by r cube. Right? Yes. Let us rewrite it, Ray. Sir, gm by r cube can be written as r square into r. Ide kada. So r minus d divided by r. Ante. So, sir, gm by r square into 1 minus d by r. Ante enti ra, gm by r square is your original gravity kada. Yes. So, sir, g at depth d is equals to g into 1 minus d by r. This is a proof. If you don't understand the proof, you directly remember the result. Result enti, sir, without proof, gonad, because the internal sphere is only contributing in the field, not the external sphere. Chusko. I want a field at this point kada. So if this is my sphere, I want this field at the internal point. So internal point ante, I have two different spheres. The first sphere is the internal sphere, okay, and the second sphere is the external sphere. So can I say that this is a combination of two spheres? This is the internal sphere plus this is the external sphere, okay? This is the external sphere, but it is not a sphere, it's just a shell. It's just a shell. And the internal part is vacuum, hollow. This is hollow part, okay? This is a hollow part, and here you have the volume. Ade kada? Yes. So when I am talking about this point, Gunat, when you are talking about this point, where is it? This is external to the inner sphere and internal point to the external sphere. Ide kada? So this sphere, hollow part, it is a hollow part kada. So this is not contributing. This bigger sphere is not contributing. Why? Because the point is internal point. It's a very good question actually, okay? The point is an internal point and field inside hollow sphere is equals to 0. Always remember, field due to the hollow sphere is 0. Now it is gone, Ante we are only left with this sphere now. Eppudu we will treat this as our individual sphere. What is the radius of this sphere? This is r minus d. Ade kada, if this distance is d, this should be r minus d. So we treat this sphere as an individual sphere and we write the field at the surface of this sphere is equals to gm by r square. R square ante radius, m ante the mass of it. Okay? This is how we do it. Next, so at a depth, what did we get the formula? Right? G into 1 minus d by r kada. G into 1 minus d by r. Chuskondi. Okay. Next, what were the factors? Height, depth complete ayindi kada. Height and depth are completed. Height complete, depth complete. On the surface is simply gm by r square. On the surface, number third, g on the surface is equals to gm by r square. You can simply say, sir, 9.8 meter per second square, leda 10 meter per second square. Next, we are interested about equator and poles. Chuskondi. So I'm talking about G at equator and I'm talking about G at poles. Okay? And the shape of the earth, so the shape of the earth is not perfectly spherical. Okay? The shape of the earth is not perfectly spherical. It is little tilted, something like this. Something like this. How is the shape? How is the shape? Chappandi andariki. Not able to draw it. Something like this, okay? It is not exactly sphere, okay? The distance, so these points, we call it equator points. Ante equator line, ade kada? Yes. So this is my equator. This is my equator point. This is my equator point, okay? Equator, equator. And these are my poles andariki. So this is the north pole of the earth. This is the south pole of the earth. Okay? Yes. The problem is the distance here, RP, it is not equals to the equator distance. Ade kada? Yes. So this is my equator distance, RE. Ade. So when you are talking about equator, the simple fact is that the equator distance is more than the pole distance. Ide kada? Yes. Equator distance is more than the pole distance. So you can simply say, sir, E at the equator, leda G at the equator, acceleration due to at the equator is G m divided by equator distance. Ade kada? Finished. And at poles, what do you say, sir? At poles, G at pole is equals to G m divided by distance of pole whole squared. So these are the two factors. Okay, G m by RE square, G m by RP square. Okay, third completed. Fourth one, G at the equator is equals to Gm upon radius of equator whole squared. Fifth one is G at pole is equals to Gm upon radius of pole whole squared. Now let us talk about the rotation of the earth. Okay? So if this is the earth shape, okay, yes, rotating ante enti sir, this earth is constantly rotating about the axis with an angular speed omega. Omega is the angular speed of the earth. Okay? Who said earth is flat? Earth is flat, huh? చూసుకోండి. If you want some random distance, so this is the center of the earth. This is the center of the earth. ekkadi nunchi I want the acceleration due to gravity at this point. Radius is r, angle is theta, leda you angle call it as phi. Whatever you want to call, you can call it as angle theta. Okay? Angle is theta, radius is r. Automatically this distance becomes r cos theta. Ide kada? Sin theta, r sin theta. Let us do one thing, let us change the angle, okay? To avoid the confusion, let us say this angle is theta. Because the books follow the similar method, okay? And I don't remember something known as sin theta. So let us call this angle as theta. If it is theta, cheppandi. This angle automatically comes out to be r into cos theta. Ide kada? Ide theta unte, this is also theta. Alternate angles, parallel lines, alternate angles, cos theta. Hi, good evening, good evening, good evening. Good evening, andariki, good evening. So this distance is r cos theta, ante kada? Yes. Earth is rotating with an angular speed omega. Omega tone rotate cheyalante, there should be a centripetal force. How much, sir? Sir, how much centripetal force, sir? Sir, m omega square r. Ante omega square r is the centripetal acceleration. Oh, perfect. So, sir, there will be a centripetal acceleration outside ra. Enta, sir? Omega square into radius. Radius ante r cos theta. If you are not understanding proofs, don't worry, remember the results only, ra. So sir, this centripetal acceleration is in the right side. Right side. Kani, my acceleration due to gravity is towards the center, sir. So em cheyali, sir? You resolve it. Ela resolve cheyali. The first component will be here. The second component will be here. Okay? If this angle is theta, this angle also comes out to be theta. Hey, opposite angles ra, chuskondi. So if this is omega square r cos theta, this will become omega square r into cos theta and cos square theta. Other. Oh, nice. What about your acceleration due to gravity? Cheppandi. Your acceleration due to gravity, sir. Sir, it is equals to g at point theta is equals to g minus, hey, cheppo. What is it, sir? G minus omega square. Leda, you can take r omega square cos square theta. Ade. This is due to the rotation of the earth. Andariki chuskondi. This is due to the rotation of the earth and the position also. Okay? This is the rotation. G minus r omega square cos square theta. Where is it? Formula list. Okay. So G and angle theta is equals to G minus r omega square cos square theta. Okay. It is all about your acceleration due to gravity. Okay. You remember the formulas only. Good evening, all of you, good evening. What is the time, Ray? 4:24, kada? Yes. So let us take a break. Okay. So after the break, we are going to discuss Hi. Hello. Correct time kada? Yes, correct time. 5 p.m. I'm good with times, right? Perfect. So, let us start with our remaining discussions. What are the remaining discussions, sir? Yes. So acceleration due to gravity completed, right? We talked about gravitational field. దాని తర్వాత we talked about acceleration due to gravity. అదే కదా? Yes. So ఇప్పుడు we'll talk about gravitational potential అందరికి చూసుకోండి. So now I'm interested only about gravitational potential. Sir, what is gravitational potential, sir? మరి ఎలా డిఫైన్ చేయాలి? How to define it? Yes, gm by r, but what is it? చూసుకో. You have a big mass capital M. Okay, you have a big mass capital M. మరి ఇదే small mass small m. Okay, small mass small m. Initially, let us say the distance is infinity. అంటే ఏంటిరా? Infinite distance ఉంటే there is no force of attraction between the particles. అంటే ఏంటిరా? అంటే it is hey, you understood, whatever it is, you understand this. So you see that this point mass is m is there, okay? Point mass m is there. Initially it is at infinite distance. Infinite distance ante it is not in the region, it is not in the range of the force. Ade kada? Yes. Ippudu nenu em chestha unte I am slowly pushing it. Hey, after that attraction will be there, but remember, at each and every single point, this is my mass m kada? Yes. There is the force of attraction. What is the force of attraction, sir? F is equals to g into capital M into small m by r square. Ippudu it has entered the region of attraction. It has entered the region of attraction. What I am doing now is I am taking an external agent. What is the function of that external agent, sir? At each and every time, that external agent is making sure that whatever force is applied, he is applying the same amount of force in the opposite direction. Ekkada kuda F. Now the problem is, this force of attraction, it is not constant, as the distance is decreasing, the force is increasing. Ante telusa? Okay? Yes. That means as soon as the distance is decreasing, force is increasing, ante attraction is increasing. To counter the same force, the external agent should also increase his force. Ade kada? Yes. Very good. Chudandi. So let us say force applied by the external agent is towards the right. Displacement ekkada unnara? Where is the displacement? Displacement is towards the left. Force towards the right, displacement towards the left. Ide kada? Yes. ఇప్పుడు I have to talk about work done by external agent. చెప్పండి అందరికి. Work done by external agent is F bar dot S bar. ఇదే కదా. What is force రా? Gm by r square into displacement is r. I'm taking it. You understand. Displacement, let us say ఎక్కడి నుంచి ఎక్కడి వరకు the displacement is r only. Okay? It was here, it came here, the displacement is r. కానీ displacement right లో, displacement left లో, force right లో ఉంటే it will be negative work. అంతే కదా. This r gone రా. So work done by external agent is equals to minus g into capital M into small m divided by r. This is the work done by external agent రా. But నాకు potential కావాలి కదా. Potential is equals to work done by external agent divided by the mass. ఏం mass రా? Whatever mass the external agent is stopping. Small m. అంటే minus g capital M small m divided by r by m అంటే mm gone రా. It is equals to minus g into capital M divided by r. I call this as gravitational potential. What is gravitational potential, sir? Gravitational potential is nothing but work done by external agent per unit mass in bringing that mass from infinity to a given distance r. From infinity to a given distance r. This distance is r. Ante kada? Yes. What is potential, sir? Potential is nothing but work done by external agent in bringing a unit mass from infinity to a given distance r against the force of gravity. What are you talking, sir? How much will I remember? Remember the formula. Okay? Just formula gurtupettukondi. You don't have to remember the derivation. There is integration used over here. Okay, it should be done via integration, but I skipped it because I don't want too much headache for you guys. Okay. Yes, తీసుకోండి. So for a gravitational charge, electrostatics lo ra chusko. If it's a positive charge q, what did we say? Potential V is equals to kq by r. If it's a negative charge q, what did we say, sir? Potential is equals to minus kq by r. కానీ gravitation lo all the times if you have a mass m, ఈ mass కోసం you will simply say that the potential is equals to minus gm upon r. r అంటే the distance. ఇదే కదా. What did I say? I told you that work done by external agent per unit mass is the potential. అంతే కదా. So ఇక్కడ నుంచి what you can say, sir, work done by external agent is equals to potential into mass. V into m. Hey, work done by external agent ra. Work energy chapter completed kada. Gravitational force is a conservative force. So whatever work you do, it is stored. Conservative ante the work is conserved into energy. Ante the work will be converted into the potential energy. Potential energy ante enti ra? Now the another topic that comes into the scenario is your gravitational potential energy. చూసుకోండి రా. ఇది చాలా ఇంపార్టెంట్. ఓకే, ఇట్స్ వెరీ ఇంపార్టెంట్ కన్సెప్ట్. వెరీ ఇంపార్టెంట్ కన్సెప్ట్. రిమెంబర్ దిస్. ఓకే, ఇఫ్ యూ హ్యావ్ టూ masses రా, ఇదే నా మాస్ క్యాపిటల్ M, దిస్ ఈజ్ మై మాస్ స్మాల్ m సెపరేటెడ్ బై ఎ స్మాల్ డిస్టెన్స్ r. చూసుకోండి, your gravitational potential energy represented by the letter U, and it is equals to, sir, mass into the potential due to the bigger mass V, capital M, not small m ra, capital M. ante kada. What is mass m ra? M only. What is potential due to capital M, sir? Minus G into capital M divided by R. Ade whatever R you want to take, you can take it. Edaina. So the gravitational potential energy stored is minus Gmm by R. Ade. So this is the gravitational energy stored in the system. Ante entira, this mass is also having this much amount of energy. This mass is also having this much amount of energy. Ante kada. Now, based on this, they will attract. Hey, they are attracting ante entira. This energy, potential energy, is converting into the kinetic energy of the system. Ardhamaindi? Okay? Yes. So you can simply say, sir, the energy that is there in the form of potential energy, you release them, they are attracting until their speeds are increasing, until their kinetic energies are increasing, until the potential energy has been converted into kinetic energy. Okay. Next. Let us take a question, okay, all of you. Let us take a question. Choose ఇదే నా మాస్ క్యాపిటల్ M, okay, and this mass is actually fixed అంటే ఏంటి తెలుసా? You have been sticked it, glued it, you glue this mass, okay, this mass is fixed. Good evening Gitanjali, good evening. Fixed అంటే glued, okay, you glue this mass, okay, yes. మొదటిగా I have another mass small m అందరికి. Let us see how many of you can answer it, okay. Initially, the distance between the two masses was somewhere around 4 times r. Okay, this was the initial distance. In instance low, let us say the mass is already getting attracted towards capital M. Okay, attraction kada, gravitational attraction ra. Let us say the speed is u. Andariki, the speed is u. Attraction is happening, speed increasing. Let us say the particle now has approached the distance equals to 2r. Okay, ఇప్పుడు నాకు స్పీడ్ కావాలి. What is the value of v at this instance where the distance has been reduced to 2r from 4r? ఎలా క్యాలిక్యులేట్ చేయాలి సార్? To this, you can take the question also, okay? Question. A mass, capital M, is glued and small m is initially moving towards capital M under mutual లేదా అండర్ గ్రావిటీ రా, ఓకే, a mass m under gravity, full stop. If initial distance లేదా initial separation was 4r, final separation is 2r, find final speed. Chala important question, okay, it's a very important question andariki. What you have to do, sir? Energy can neither be created nor be destroyed. Yes, Rupesh gaming journey, hi, hello. ఈ కేసులో చూడండి అందరికి, ఇనిషియలీ దిస్ ఆబ్జెక్ట్ వాజ్ హ్యావింగ్ సమ్ కైనెటిక్ ఎనర్జీ. ఎంత సార్? కైనెటిక్ ఎనర్జీ ఇనిషియల్ is equals to half mu square. Potential energy, yes, it is there. Potential energy is equals to minus g m1 m2 divided by r. So na total initial energy మాట్లాడాలంటే you can say, sir, initial total energy is kinetic energy plus potential energy అంటే half mu squared plus, not plus, right, should be minus, negative potential energy కదా, g capital M small m divided by 4r. So this is my potential total initial energy రా. ఫైనల్ సిచ్యువేషన్లో చెప్పండి, ఫైనల్ సిచ్యువేషన్లో కైనెటిక్ ఎనర్జీ ఫైనల్ నాకు తెలియదురా, హాఫ్ mv స్క్వేర్, నాకు vకి వాల్యూ కావాలి, ఇదే కదా. ఎస్, పొటెన్షియల్ ఎనర్జీ ఫైనల్ చెప్పండి, మైనస్ g ఇంటూ m1 ఇంటూ m2 డివైడెడ్ బై 2r. అదే, ఓ పర్ఫెక్ట్ సార్. అంటే ద టోటల్ ఫైనల్ ఎనర్జీ is equals to total kinetic energy final plus total potential energy final అంటే half mv square minus g capital M small m divided by 2r రా. ఇదే, సో ఇదే నా టోటల్ ఫైనల్ ఎనర్జీ రా, అందరికీ చూసుకోండి. This is my total initial energy, this is my total final energy, they must be same. Why, sir? Because gravitational force is a conservative force రా. అదే, so what you say, sir? Initial energy is equals to final energy. అంటే ఇనిషియల్ ఎనర్జీ ఏంటిరా, half mu square minus g capital M small m divided by 4r should be equals to half mv square minus g capital M small m divided by 2r. m gone. అదే కదా, నాకు v square కావాలంటే send everything this side రా. ఇదిగో 2 కూడా gone, అంతే కదా. Yes, so what you are left with is, sir, m is also gone, sir. Sir, I'm gone ante u square is left. U square minus g into capital M divided by 2r should be equals to v square minus g into capital M divided by r. You send it that side ra. So V square is equals to U square minus G into capital M by 2R plus G into capital M divided by R ante U square minus G plus G M divided by 2R. ఇదేనా V square కి వాల్యూ V is equals to root of U square plus G M divided by 2R. అదే. Are you understanding? Too much complicated kada? Why are you taking so much complicated questions, sir? Yeah, it's very easy. Very easy. You can take it as you want. Leda V square is equals to U square plus 2S. V square is equals to U square plus 2S re. Hey, V square equals to U square plus 2S. Hey, value untara. Acceleration inta, sir. Acceleration is field. Sir, U square is U square minus 2 into acceleration inta, sir. Should not be minus, it should be plus. Acceleration is J into capital M divided by, it's a variable acceleration, right? You cannot do it this way. You will have to take integration and differentiation, ra. Chusko. This is the final answer. Eh? If you are understanding, well and good. Not understanding, let it be. Okay? Now, let us talk about energy of system. System ante enti ra? Huh? Energy of system ante enti? Ide na first mass M1. This is my second mass M2. This is my third mass M3. Let us say the distance is R. Let us say the distance is A. Let us say the distance is B. Cheppandi. Total potential energy is equals to U1 plus U2 plus U3. Ante kada? U1 value enti ra? U1 is between these two. M1, M2 lone unte potential energy. G minus G M1, M2 divided by distance entara A. Plus minus G M2 M3 distance entara M2 M3 lo distance is, sir, R. Plus minus G M1 M3 divided by distance is B. This is your total potential energy. Andariki చూసుకోండి. No, you can't expect this type of question. But if it's 2025 question paper, then you can expect it. Okay? It's a 2025 question paper, you can expect it. But usually they will not ask this much. Okay? Usually they will not ask this much. Okay? Just remember this total energy formula. Total energy is minus, take it minus common. Okay? G M1 M2 divided by A plus G M2 M3 divided by R plus G M1 M3 divided by B. Other. This is how you write the total energy of the system. Ante kada? Total energy of the system has been successfully written. Okay? Now, చూసుకోండిరా U is equals to minus G M divided by R. ఇదే కదా? Yes. As the distance is increasing, andariki, as the distance is increasing, you tell me, okay, as the distance is decreasing, sorry, when they are coming close kada, as the distance is decreasing, this term increasing, కానీ it's in the negative form. So as the difference is decreasing, distance is decreasing, separation is decreasing, potential energy is also decreasing. చూసుకోండి. So this is the graph of your potential energy. Okay? When your R value is decreasing, potential energy is also decreasing. This is U versus R. Just remember the graph. Graph ide ante important. Ade. Nothing else. Only the graph is something that you have to, you skip it. Rupesh gaming journey, if this questions are asked in that pressure, if you have confidence, you can do it. If you don't have confidence, you skip it. Okay? If you think that no, it is going to take a lot of time, you skip these questions. It's completely silliness, foolishness to attempt the questions which you don't think you will be able to do it. Okay? Next. ఇప్పుడు చూద్దాం రా. Let us talk about orbital velocities. దాని తర్వాత we will immediately take your escape velocity, okay? Velocities of satellites అంటే satellite motion రా. After the satellite motion 5:20 this lecture was supposed to be completed in 1 till 6 p.m. right? I think it will take some more time, 6:30 or something like that. చూసుకో. Orbital velocity అంటే ఏంటి సార్? This is my mass అంటే this is my earth capital M. Mass is capital M, అదే కదా? Now there are some satellites that are revolving around this earth. చూసుకోండి. So this is your satellite ray. Okay, this is your satellite. This is your satellite revolving around the earth. అందరికి చూసుకోండి. So if this is your satellite, let us say the mass of this satellite is small m. చెప్పండి అందరికి. Circular motion perform చేస్తున్నారు కదా? So circular motion ఉంటే what you can say sir, there is a force required for circular motion, centripetal force, right? Centripetal force. కానీ which force is acting as centripetal force? ఈ కేసులో if the distance is r, అందరికి సింపుల్ అదే కదా? చెప్పండి. Centripetal force should be equals to m into v square upon r. Very simple. This should be the force always directed towards the center to perform your circular motion. కానీ ఒకటే ఫోర్స్ యాక్ట్ చేస్తున్నారు రా, గ్రావిటేషనల్ ఫోర్స్ అంటే this value must be equals to your gravitational force gm upon r square. అంతే కదా? small m ఒకటే r gone రా. Sir, v square is equals to g times capital M divided by r. అంటే v is equals to root of g times capital M divided by r. What is r, sir? r is the radius of the orbit in which the satellite is moving. Very good, very good. Maitri has asked some question, okay? I don't know if Maitri is there or not, but if possible, if that question is accessible, we will take that question. Okay? చూసుకోండి. So let us talk about time period of rotation. చెప్పండి. Time period is how much, sir? 2 pi r divided by speed. అదే కదా? Yes. Substitute చేసుకోండి sir. Values 2 pi r అంటే 2 pi r. Speed value అంటే root of g times of capital M divided by r. ఇదే కదా? So total time period is 2 pi r root r divided by root of g times m. అంటే time period of revolution could also be given as t is equals to 2 pi by root of gm. ఇది మొత్తం constant quantities రా. 2 is constant, pi is constant, g is also constant. For a planet of mass m, ఇది కూడా constant. అంతే కదా? Yes. Multiplied by r root r. You can directly say r to the power 3 by 2. అదే. చూసుకోండి. So this is your time period of satellite. అంటే you can simply say sir, time is directly proportional to the radius లేదా the distance of the orbit to the power 3 by 2. అదే. There was some question I believe. So I don't know what was the question. Maitri is there? Maitri not there. Okay. Hi Vaishu, hi. So there was some question, I don't know, that question was something like this. So there was this satellite, if I could recall that question, okay, if I could recall that question was something like this: 6 times of radius of earth, time period was t, అదే కదా? And then I believe there was some 2.5 radius of earth, ఇదే కదా? 2.5 re, నాకు time period కావాలి, ఇదే కదా? Yes, so you can simply say sir, t1 by t2 is equals to r1 to the power 3 by 2 divided by r2 to the power 3 by 2. ఇదే r1 వాల్యూ ఎంత సార్? 6 times of radius of earth to the power 3 by 2 divided by it is 2.5 re to the power 3 by 2. అంటే you can simply say sir, 6 by 2.5 re gone కదా? Yes, to the power 3 by 2. ఇదే. So this is t1 by t2. Take the reverse, you can say sir, t2 divided by t1 is equals to 2.5 divided by 6 to the power 3 by 2. You can simplify it, okay? I don't remember exactly the question, but there was it asked by Maithili, okay? Next. Hey, orbital speed completed, time period completed. Let us talk about escape velocity, okay? Let us talk about escape velocity. Escape velocity ante entira? You imagine this, okay? You imagine this. I don't know if there is this motion or not. You understand, this is your mass of the planet M kada? Let us say this is mass of this earth. Mass of this earth capital M, okay? Hi. Yes, Maitri is back, right? Okay. Maitri, what was the question, Maitri? Sorry, Cheppo. What was the question? You're asking some question, kada? That question. Anyways, let us talk about your escape velocity. Chuskondi. What will happen? I'm not going into the much details. Ekkad kuda, I'm directly writing the formula. Remember the formula, okay? You remember it. Chuskondi. What will happen if I throw this object with some speed v? It will come back. Ade kada? Yes, it will come back. Yes. So if I increase the speed, it will go little away, come back. Increase the speed, again little away, come back. Increase the speed much more. It will go and it will never come back. Minimum speed, that speed is known as escape velocity. You remember, escape velocity is equals to root of 2gm by r. R and the radius of the earth. Are you understanding? R is the radius of that planet. Hey, all of you. What was orbital speed, sir? Orbital speed was root of g times m divided by r. And your escape velocity root 2gm by r. Ante kada? Yes. So this is the expressions that are required. Okay. Escape velocity is the speed with which you have to throw the object from the surface of that planet and the surface of earth. Okay? Surface of earth. You throw it with this speed, it will never come back. What about orbital speed, sir? Orbital speed ante when the satellite is revolving around the earth, its speed must be root gm by r. Gm by r speed undali. Then and only then. Okay? Then and only then. No, you can't say always that. Okay? You can't say V is not perpendicular to VO, but VO is always directed towards the tangent. And VE could be anyhow. That does not matter if you are throwing it perpendicular to the surface, లేదా parallel to the surface. If VE is the escape velocity for Earth కోసం, for Earth, escape velocity is 11.2 km per second. Ante entira? Ante if you throw this pencil with the speed of 11.2 km per second, it will never come back. Okay? It will be gone. Forever and ever. Gone. Tata. Bye bye. Gaya. Okay, yes. So let us talk about satellites, motion of satellites. Okay. Geostationary satellite. Okay. The time period of a geostationary satellite is 24 hours at a height of 6 RE. Okay, the time period another satellite whose height is 2.5 RE, I believe, right? Yes. Time period is equals to, you can simply say time period is directly proportional to r to the power 3 by 2. Okay. Yes. So how much time? 6 hours kada? 24 hours. Okay. So time period is 24 hours divided by how much time period? I don't know. Let us say time period t should be equals to r1 by r2 to the power 3 by 2. So you can simply say 24 by t should be equals to 6 divided by 6 times RE kada 2.5. 2.5 ante 5 by 2. All of you. 2.5 ante 5 by 2 to the power 3 by 2. So 24 by t should be equals to 12 by 5 to the power 3 by 2. 3 by 2 ante entira? Cube and square. Whose height is 2.5 RE from the surface. Okay. 2.5 RE from the surface and 24 by t should be equals to 12 by 5 root of 12 by 5. Ide kada? Yes. So 12 ones are 12, 12 twos are 24. You send it that side. Okay? You send it that side. So sir, t by 2 is equals to 5 into root of 5 by 12. And t is equals to 10 root of 5 divided by root 12. root 12 ante 4 into 3 kada. So sir, 5 root 5 divided by root 3, something like this. Yeah, you can take it, you can simplify that, okay, whatever it is. Time period okay, you can take it, okay, simplify it. All these are the answers ra. Chusko. So let us talk about geostationary satellites. Why should even I was MPC teacher, physics for JEE, but they gave me this NEET role, so I am playing this NEET role, okay. I actually teach to JEE. Geostationary satellites, చూసుకోండి. Geostationary satellites are important to do all the necessary communications. Communications ante enti ra, you imagine, okay, this is your earth and this somewhere here is your satellite, okay, this is your satellite. చూసుకోండి. Hey, I think I am missing some information. Maitri, I think I am missing some information, okay. I think we will have to correct it. I read the question in a wrong way. The distances are given from the surface, kada. From the surface, not the center. From surface of earth. So the distances will change, ra. Absolutely. So this is RE and ikkada nunchi it is 6 RE, kada. Yes. First distance. Second case lo, this is your radius of earth, RE, and this is your 2.5 RE. So the distances will change. For sure it will be 7 RE and here it will be 3.5 RE. So radii 1, R1 is equals to 7 RE, R2 is equals to 3.5 RT. So sir, T1 by T2 should be equals to R1 by R2 to the power 3 by 2. T1 ante enti ra? T1 is given as 24 hours, ide kada, divided by T2 is T2 only, is equals to R1 values are 7 RE divided by 3.5 RE to the power 3 by 2. RE gone, it is 2 only, okay. So 24 divided by T2 is equals to 2 to the power 3 by 2. 2 to the power 3 by 2 ante it is 2 root 2, okay, it's 2 root 2. 2 root 2. Take the ratio, sir. So T2 divided by 24 is equals to 1 by 2 root 2 ante T2 is equals to 24 by 2 root 2 ante 12 by root 2, that is 6 root 2 hours, whatever it is, okay. I little had the confusion that the distances were given from the center, okay. Yes, so this is the answer, 6 root 2 hours. This there, it's there, yes, it's there, option A is there, right. Next, geostationary satellite ante enti, the satellite in which the communication happens, okay. Yeah, yes, I have, okay, don't worry, I have, okay, I have, right. I'm actually writing a book, in JEE, okay. Good questions in it, good questions, but anyhow, we are focusing over here. Chuskondi. This is the satellite, ra. When the earth is moving, chusko, how should I tell you? Let us say this is earth, okay, I am earth, and this is satellite, okay, this is satellite. And these are the two places. So this is place number 1, okay, here. The person is standing here, okay, this is a person. This is a person that is standing, okay, this is a person, okay, this is a person. He sent his call, signal. That signal went straight to the satellite and ekkada nunchi the signal has to come to this mic, okay, this mic. Chuskondi, this mic. This is a person, he is sending signal to the satellite and ekkada nunchi the signal is directly received by the mic. What will happen if the satellite is keep on moving, ra? Do you think the signal will be able to reach it? There will be lag, yes. So all the times, the position of this satellite must be fixed with respect to the earth. And when the earth is moving, the satellite should move equally with this earth. Understanding? Are you able to understand? Okay, yes. So this is the pencil and a satellite, this is the earth. the geostationary satellite must be rotating or revolving with the planet itself. Why did I do anti-clockwise, clockwise? Because this wire was getting stuck. Okay. Anyways, so if the earth is moving something like this, your satellite should also move along with the earth, ra. Are you understanding? Ante enti ra? How much time does the earth take to complete one rotation? 24 hours. 24 hours, ade kada? Yes. So earth is taking 24 hours, ante the time period of satellite should also be equal to 24 hours. Ide. What should be height, sir? It could be anything. You can take any height. Are you understanding? You can take any height. But. The time period should be 24 hours. Enduku, sir, if the earth is exactly on the same point as the satellite all the times, that means then and only then the communication will be strong. Are you understanding? Are you understanding? Yes. Great, great. So for geostationary satellite, the time period is 24 hours. It's a very important thing. Very important thing. Okay. For any geostationary satellite, the time period of rotation must be 24 hours. Okay. Now let's talk about polar satellites. Polar satellites ante enti, sir? Time period formula good petkondi. Okay. Time period is what, sir? Sir, time period is 2 pi divided by gm into r root r should be equals to 24 hours. Now you can decide accordingly and then you can do it. Okay? You can do it. Now, polar satellites ante enti, sir? Sir, this is the north pole of earth, this is the south pole of earth. Ade kada? Yes. So the satellites only revolve around the poles vertically. So if this is your earth, the satellite revolve in a vertical way, something like this. Ide kada? Yes. Good. So this was all about your polar satellites. What else are we missing, sir? We are, I think, only missing your Kepler's law. Okay? Okasari Kepler's law are completed, ante your chapter is completed. So we are having only 22 minutes, right, for 6 p.m. So ippudu last topic of your chapter ra Kepler's law chuskondi. Johannes Kepler was the scientist who actually observed the motion of planets, around a star. You understand? Around the sun. Okay? He observed the motion of the planets around the sun. So there was a widely spread belief that geocentric theory ante enti, sir? Our earth is the center of the universe and everything, stars and sun, rotate around the earth. This was the theory. Ade kada? Then came the scientist Galileo Galilei. Vadu, he has discovered a satellite. He said that it's not true. Whatever you are telling, whatever is written, it's not true. Earth rotates around sun and he got killed. Okay? They killed him. They killed Galileo because he said it. Okay? Yes. So one such scientist was Johannes Kepler. Okay? Johannes Kepler. He said us 3 things, ra. Okay? 3 facts chepparu. What is the first thing, sir? First thing is, when a planet moves around a star or sun, when a planet moves around a sun, the motion is not circular. When a planet moves around a sun, the motion is not circular. Ante, this is my planet, this is my sun. Chuskondi. And this is the planet kada. It's not circular motion. It's a wrong interpretation, ra. What did he say? He said that if this is your sun, the planet moves in an elliptical path, something like this. Are you understanding? If this is your sun, your planet moves in an elliptical path. What are you talking? Why would I have my relatives in Pakistan, Vaishu? Why would I have my relatives in Pakistan? No, not at all. Chusko. So this is your planet and this is your sun. Path is elliptical. Elliptical path, chuskondi. It is a very important thing. Elliptical path. Elliptical path ante enti ra? Ellipse. Ellipse ante enti sir? Ellipse ante it's a shape. And always any ellipse has two focuses. Focuses ante telusa? Circle lo we have center. Similarly, ellipse lo we have focuses. Are you understanding? Rendu focuses unnai ra. So he said that you place the sun at any one of the focus. You want to keep it here? Sare. Leda, you can shift it to another focus ra. No problem at all. This and this are same. Sun must be at any of the foci. Okay? The sun must be at any one of the two focuses of the ellipse. And the planet will move in an elliptical path. First law. Okay? Kepler's law lonchi. The first law is planets move in elliptical path. Planets move in elliptical path around sun, where sun is at any of the focuses. Focuses ante enti ra? Foci. Ante this is ellipse. Wrong. This is ellipse. Leda, this is also ellipse. Right? Diagrams, don't judge it. Okay? Your sun could be here. Ledante, your sun could be here. There are two focuses only, left and right ra. But the planet will be moving around the sun. Understanding? Your planets will be moving around this elliptical path. Dan tarvata, what did he say? These two rules, leda these two laws are very important. Chala important, okay? These two laws are very important. Chuskondi. Law number 2. What did he say? The line joining the sun and the planet sweeps equal areas in equal interval of time. Sweep equal areas in equal interval of time. Very good. Okay, very good. Ante enti ra? You imagine this is your planet in elliptical path. Ide kada? Yes. So this is your planet in elliptical path. This is your sun. Andariki chuskondi. This is your sun. Okay? Yes. And this is your planet. This is your planet. Initially it is here. So this is your planet. Okay? You draw a line kada, line joining the planet and the sun. Line joining the planet and the sun. Let us see how many of you are listening to me, okay? Line joining the planet and the sun. So this is the line that is joining the planet and the sun. Equal interval of time ante, let us say 4 seconds of time interval. 4 seconds. 4 seconds. Every 4 seconds we will be, yes, even with different focus. Different focus ante, you can just shift it. You can't shift the focus in the middle, okay? Go not. If you are assuming the focus to be in the left, it will be in the left. Leda, if you are assuming to the right, it will be in the right. Okay? Yes. You draw the line joining the sun and the planet. Let us say 4 seconds of time interval. Sir, if 4 seconds low, the planet has moved, sir. Tick 1, 2, 3, 4. 4 seconds have been passed and the planet has moved to this point. Andariki. Chudandi andariki. Hey, is it visible to you? Is it visible to you? 4 seconds low, the planet has moved this way. Ante kada? Yes. In 4 seconds, the planet has moved this way. Ippudu, you draw the line only. You draw the line. Again, you draw the line. Join it. What is the area, sir? This is the area. Ante kada? Yes. There is a little mathematics involved into it now. Okay? Little mathematics involved into it. Chuskondi. Again, after some time, the planet is somewhere here. Chuskondi. The planet is somewhere here. Set the same timer. How much time, sir? 4 seconds. 4 seconds time kada. Ee 4 seconds lo the planet has moved from this to this. Ikkada chudandi. Here 4 seconds time teeskondi. When you are taking the 4 seconds time, you initially draw the line. Okay, join the line. So this was my line. 4 seconds low, I want the same area. Okay, I want the same area, but see the shape. Little mathematics involved. Little mathematics involved. So to get the same area, can I say, sir, this and this are the same? Yes, you can say. Why? Because this distance is less, this distance is more. Understanding? Yes. Ante enti ra? Ante ee 4 seconds tarvata, the planet must have moved at this instance. So, sir, ekkada kuda 4 seconds and here also 4 seconds. Now I want you to imagine one thing, okay? Okay, now I want you to imagine one thing. If 4 seconds low, when the planet was away from the star, it moved a very little distance. Understanding? But in the 4 same seconds, here the planet has moved a good amount of distance, very good amount of distance. Understanding? So what's happening, I'll tell you. Chuskondi. So this is my sun. Okay, this is my sun. Andariki chuskondi. This is my sun. And this is my planet, okay? This is my planet. So 4 seconds, very slow. As the planet is approaching the star, speed increases and very fast it goes something like this. Okay? Chuskondi. This is your planet. Speed chuskondi. Very slow, increasing, something like this. Okay? Very slow. And then increasing, speed increases. Can you visualize? Can you visualize the speed? Can you visualize the motion? Yes. The same thing. As it is approaching close to the star, as the planet is approaching close to the star, speed increases. And it is going away, speed decreases. Coming up close, speed increases, decreases. Increased, decreased. Increased, decreased. Increased, decreased. Hey, are you understanding? Understanding, not understanding. Okay? Let us see if there is some demo page or not. Okay, chuskondi. Okay, this is the planet Earth. I don't know if you can see it or not. But okay, this is Earth. Okay, this is Earth. This is Earth. This is Sun. Okay, this is Sun. So let us imagine something like this. The motion started. Okay, the motion started moving. Crossed. Speed చూడండి అందరికి. So it is moving something like this. I give it speed something in that direction. Okay? Hey, don't fall. It's not a circular motion. For sure, it's not a circular motion. Okay? See the speed. Fast. Slow. And then increasing. Okay, speed is increasing. Very fast. Hey, this is fast speed. Now it is decreasing. Okay? Yes, independent of mass. Okay? When the planet is coming close to the sun, the speed increases. And when it is going away from the sun, speed decreases. Ade. Okay? Right. One last law. Law number 3. Chuskondi. Third law. Kepler's third law. Andariki cheppandi. Kepler's third law. Third law ante enti sir? Third law lo what did we say? For geostationary satellites, did we say that T is equals to not G 2 pi divided by Gm into R to the power 3/2. Ide kada? Square cheskodi. Square all sides. So T square is equals to 4 pi square divided by G square M square multiplied by R to the power 3. Ide kada? Yes. It's everything constant ante T square is equals to K into R cube. That means T square is directly proportional to R cube. This is Kepler's third law. When a planet is revolving around the satellite sun, when the planet is revolving around the sun, its square of time period is directly proportional to the distance leda the cube of semi-major axis to the power 3. Ide kada? Yes. So T square is directly proportional to R cube. What could be the questions asked, sir? Question is, if the distance between Earth and Sun is doubled kada? If the distance is doubled, a year would have, it's a very famous question, okay? Dash days, చూసుకోండి. Distance doubled ra. Okay, so I can say, sir, t square directly proportional to r cube ante t1 by t2 whole square is equals to r1 by r2 whole cube. ఇదే కదా? Yes. t1 అంటే 24 hours. అదే కదా? Yes, 24 hours. Initial time ra, 24 divided by t2 whole square should be equals to r1. r1 is r only, r2 is double ra, 2r to the power 3. ఇదే. So, sir, 24 by t whole square should be equals to, చెప్పండి. Hey, year kada? Year. A year ante 365 days ra. 365 divided by t. Time, days, time is there, okay? Time is there. Cheppandi. So, sir, r gone. So, 365 whole square divided by t square is equals to 1 by 8. Do the cross multiplication. T square is equals to 365 whole square multiplied by 8. Ante t is equals to 365 into square root of 8 ante 365 into 2 root 2 days. This is how you do it. Okay? If you are understanding or if you are done with this topic, then we can wind up this session. Cheppandi, ఏదైనా remaining in gravitation? Am I forgetting something? Am I forgetting any subtopic? I don't think so. Okay? Yes. Energy of satellite, one topic. Okay, energy of satellite andariki. So if this is your planet, okay, planet ante mass m తీసుకోండిరా. This is my satellite. Mass is small m. Cheppandi, total energy ante entira? Total energy of satellite is equals to kinetic energy plus potential energy. Ante kada? Yes, kinetic energy is half mv squared. Potential energy minus g capital M into small m divided by r. Ide kada? Yes. So half is half, m is m. V square ante entira? V is orbital speed. Root gm by r. Root gm by r. Yes. Square it. Gm by r is left. Minus g into capital M into small m divided by r. Ide kada? You take it something like this, g capital M small m divided by 2r minus g capital M small m divided by r ante minus half g capital M small m divided by r. This is the total energy. Ante negative ra. Total energy is equals to minus half g capital M small m divided by r. Ide. Okay? So with that being said, our chapter ends here. Okay, 6:30 lo you have one more session. Deentlo we will be covering your rotational dynamics. Rotational dynamics anna rigid dynamics anna same. Okay, everything is same. Chudandi and tell me what else is remaining. As long as PYQs are concerned, hey, all of you. If Rupesh gaming journey, if the time is given in seconds, take in seconds. Given in hours, take in hours. Okay? Given in days, years, take in that same respective frame. Okay? Yeah, Gonad, I'm fine. Perfect. So if you don't have any doubts, then we can wind up with this session. Okay? Sure. Good. Right. So, yeah, it's fine. Our 50% syllabus is completed, I can say, okay? We started in the second week of December. 8th of December, I remember the dates. 8th or 9th. 8th or 9th of December we started. 9th December nunchi till this point. What is the date today? 15th of Jan kada? Yes, it's hardly around 1 month. Not even 1 month, I was, for 7 days. So even somewhere around, absolutely. Your entire syllabus will be completed by the end of January, లేదా mid of February. Anyhow, your syllabus will be completed by the middle of, I'm talking about physics. Only about physics, okay? I don't know about any other subject. Okay? Yes. So your entire syllabus will be completed by the end of this month, లేదా by the mid of the February month. దాని తర్వాత my plan is to take only the PYQs, 4 hours complete session, and we'll just be taking PYQs for each and every chapter, okay? For each and every chapter. This way, let us see if you can cover all the chapters PYQs till your NEET examination, okay? Once your entire PYQs have been completed, you only watch those PYQs and go and attempt your examination. You don't need anything else, okay? Anything else. For anyone who is just going to crack the NEET examination in this time only, the best tool you have is PYQ solving. I would say that. Okay? Yes. Chalo. No, I don't watch cricket. Okay? I don't watch it actually. Yes, Rupesh, PYQ is more than sufficient. If you know formulas plus PYQ, the deadliest combination for NEET, okay? The deadliest combination will be your formula plus your PYQs based on whatever time you have. You can't take much risk. It's completed. Glory life. Newton's laws and friction are completed. Units and dimensions, basic mathematics, kinematics 1D, kinematics 2D, Newton's laws, friction, work power energy, center of mass, gravitation, rotation will be completed by today itself, current, electrostatics, current electricity, capacitor, magnetism, all of them are covered, okay? All of them completed. Uh, 6:30 you will be having rotational dynamics. Okay? We will cover it. We will finish it by the end of today itself. Okay? Rotational dynamics will be completed by today itself. Repu, if possible, we will take 2 more chapters. Okay? 2 more chapters will be completed tomorrow itself. One shot. Your EMI, electromagnetic induction. And the second chapter that I would be covering would be your waves are there, but I don't think it should be sufficient to take the waves for now. Okay. For sure, tomorrow your electromagnetic induction. Dan tarvata, if possible, mechanical properties of solids. Okay, properties of solids. Ante entira properties of solids lo. Yes. properties of solids, you will be talking about Young's modulus, stress, strain, energy, all these things. Bulk modulus, shear modulus, shear stress, shear strain, all these things. The 2 chapters will be completed. Tomorrow, EMI from class 12th, the second year nunchi, and class 11th, you will be completing your properties of solids. Day after tomorrow, we will complete fluids mechanics, and then if possible, we will jump to waves. Okay, fluid mechanics, then tarvata oscillations. So if you are starting waves, then you must be doing it in a very proper way. Waves kosam you must start with oscillations. Oscillations ante simple harmonic motion. Then you start with waves, and then we start with wave optics. So these are the 3 consecutive chapters. They must be done in a consecutive way. Okay? Right. Yeah, modern physics will take it at the end. Okay, modern physics will be in the end of the syllabus covering process. Last lo modern physics తీసుకోదు. Then you have heat, mechanical property, thermal properties of matter, then thermodynamics, kinetic theory of gases. Adi kuda. And then we have geometrical optics, ray optics kuda antaru. Geometrical optics, I think, will need 1 full day. 1 full day and at least 7-8 hours. 8 hours ki lecture will be there for geometrical optics. No, why should I don't watch? Okay. So I have decided, okay, I have decided what flow to take and how to take. Okay, so if you don't have any problem, we can wind up this session, okay? Andariki. Okay, bye-bye, good night all of you. Yes, we'll be back at 6:30 p.m. with a whole new chapter, rotational dynamics. Okay, good, sure, bye. Bye all of you, bye. Like the video first of all of you, andariki, like it, right? Hey, like it. Like the video, because the like ratio is very less. Thank you so much, Parimala. Bye.